Hey guys, good to see you. Who we got here? Hey Dr. Miz, hey Yaroslav, Commodore, Andy, Dardeok. Nice to see you guys. Hope your Saturday's been as pleasant as mine. Nice and relaxing today. I've been watching Fortnite World Cup actually, which has been strangely addictive. Hello Amok. I'm going to call you Amok because I can't say that whole word. So I'm drinking 1 glass of white wine, and then I've got a whole bottle of red to drink, which I'm going to open now actually so it can breathe a little bit. Yeah, I'm not a big fan of Fortnite, but the World Cup has been quite interesting to say the least. Good, I'm going to knock this over. That'll be fine. Hi Steps. Okay, so before we start, I want to let you guys know, for patrons and subs of the channel, we've got this new tool called Flubits. I'll show you the screen there. Where's that so I can actually see what's going on up here? Okay. So Flubits is a way for you guys, if you want to connect to the stream, to connect to the code live, so you can see edits as I make them, and you can run the code yourself in whatever editor you've got. It's got support for quite a few editors. Let's have a look what editors it's got support for. Gonna keep taking me to there, isn't it? Go to help. So it's got support for these editors out of the box. So these editors have a plugin. Needs more bigness. There you go. So if you're on any of those 5, you can just install a plugin, and you'll be able to connect to the code live as we write it. It will be view only, because obviously I don't want everybody editing the code as I'm editing it. That would be an absolute nightmare. But it will allow you to look at any of the files, not just what I can see on screen. And so that's an exclusive perk for patrons and stream subs. So if you want to, you can go to this site, create an account, send me your account name, so this bit here, and I can add you to the users. Oh, thank you for the bits, Andy. First drink on you. Cheers. What are you all drinking? I saw Don was getting a cognac, which is a very nice choice. I do like a cognac now and again. Yeah, you'll be able to connect to this, and I can add you in here. So at the moment I've got Andy and Dom in there. Coffee. I do like a coffee as well. I've got to have 1 coffee every day, but that is just purely caffeine addiction, because if I don't I get a headache. So if you've already got it installed, I'm going to drop a link now into the chat. You can connect to this workspace, and I'll show you how to do that through Sublime. It's a little bit different, I'm guessing, for other editors, but I'll show you how to connect through Sublime. I'm guessing it won't be very different. Oh, and if you're not using one of these editors, say you're using VS Code, which I know is another popular editor, there's also the no editor option where you can install Flumatic, and Flumatic is just a node script that keeps a folder on your machine in sync with the work that we're doing, so you can still open it and still work with it in things like VS Code or Eclipse without actually needing a plugin. But I'm going to show you how to connect to it using the plugin, and from now on I'm going to always connect to the code this way. So with the plugin installed on Sublime, you just right click on anywhere on a blank page, blank project, go to Flubits, join workspace, and then in this bottom bit here you just paste in the URL, and that's it. It's that simple. Also, if you overwrite 1 local file, fetch readme, yeah, okay. So because I've got write access, I'll get these kind of weird git-like overwrite or whatever. So you can also, if you don't want to do that, if you go to the project in here and view the project. You can also go to web editor and you can see the code here in the web editor as well as we move along. So I can see now I've got Andy and Dom connected, and you'll see. So if you open up a file, let's go into start, and you'll see as I type in start on here, it should edit on there. So let's find start. So if I just type 1 2 3, you'll see we get it here in here. So, and you should be able to press F7 from inside start ASM and just run the program that we have so far as well. Hi Acmefin, welcome to the channel. Cool. So if you guys are on my Patreon or you're a sub on the channel and you want access to that, just send me your username and I can add it. It's very, very quick to add. I can do it while we're on stream. Send me a private message on Twitch is probably the best, because then I should see it pop up, I think. Or you can send it me in channel. It's only your username. It's not a password or anything. It's not, you know, it's nothing secret. But it might be a bit harder for me to check in channel chat. Whenever we do a break, that's probably the best time to do it. So if you're not already connected now, send it me in the next few minutes. I'll try and keep an eye on the next few minutes. Otherwise, just wait till the break. Okay, let's start. So what we managed to achieve in the last stream was we got our little player on the screen and we got him moving around. He started in the top corner, and then we started looking at adding collision in. And what I realized afterwards, probably because I was quite drunk, to be honest, while I was doing this, is that I didn't really think properly about how this is going to work, and I'll try and explain why now. So if I open up SpritePad, that's Charpad. Oh god, which one is it? I've got to find it now in my bits. Okay, so this is our little player sprite. I don't know how easy that will. Oh, you can just about see it there. So we want the collision. If we're just thinking about collision of the floor that he's standing on, we won't worry about the ceiling or the walls yet. We'll just think about the floor. We want each of his feet. So these 2 pixels here and here, colour them green for now so you can see. So we want each of those to know if it's on ground or not. If either of them is on ground, then we don't fall. If neither of them is on ground, then we want them to fall. And because they're exactly 4 pixels apart, well, 2 pixels apart, they cover an entire char, I originally thought we just needed 1 character underneath him. But the problem with that, as you can see, is as I move across, the block that it thinks I'm on, it's always going to be one away, or half a block away. So I think what we're going to do instead is we're gonna check under each foot individually, and then that way we're either stood on 2 blocks like that, or we're stood on 1 block like that. We can use a logical OR operator to combine the kind of collision values in these 2 blocks, and then we'll find out if either of them, if this one or this one is the floor, then we don't fall. So that should make it a little bit better, and actually it should make the collision way more accurate than doing it the other way. And I think when we look at doing wall collision as well, we'll do a similar thing where we'll look at the bottom pixel here and maybe 1 2 3 1 2 3 4 1 2 3 4, maybe 1 around here. But to be honest, with this method we could do it to there as well. It really doesn't matter. In this case it would always be spanning two character block, but we'd get a very accurate take on where we are. So we'll start by doing the floor first, because then the routine that we write can kind of be reused for elsewhere. Let's begin with that. Okay, so just quit out of that. the good news is as well, the vote finished a dead heat between jump on or melee to kill and absorb or eat. So we're going to do a combination of the two. So we're going to do some kind of melee attack where you will attack an enemy to stun them, and then you will absorb them to kill them. So it'll be very similar to Parasol Stars or Bubble Bobble, where you'll do an attack, it will put them in some kind of stun state, and then you'll have maybe 10 seconds to absorb them before they wake up and begin and carry on kind of with their original behavior. I think we should probably have, yeah, as Acmiffin says, I think we should have something like a baseball bat, something so when you hit them, they go flying across the screen. Because otherwise you're going to hit them, and then you can immediately absorb them. You kind of want that 10 seconds to be critical. You want to have to hit them and then go chase them. So you're kind of constantly panicking. I think that will kind of make the game feel a bit more kind of exciting, rather than just instantly eating them or absorbing them as soon as you've hit them. Okay, so is that code big enough, or do I need to go a bit bigger? Are you on Patreon, or you need to be a sub or a patron? Sorry, I should have clarified that. So let me give you the Patreon link. So you may already be. If you are already a patron, please tell me your patron name as well. Patrons. That's the patron, or you can sub on Twitch, either of the two. It's just so that the patrons, because I do everything pretty much for free anyway. The videos are all free. The kind of help in Discord is all free. I like to give the patrons and the subs something a little bit kind of supplemental to this. They're not getting anything too extra. I mean, the code is fully available on GitHub after the stream. Oh, you are on Patreon. Okay, cool. I have seen your name on there. No problem. Let me add you to that now. Oh god, what have I done? Press some kind of button and done weird things. How do I close that window? That's really annoying. There we go. Okay, so I'll do all these now, and then so we'll do this for a few minutes, and then we will start the code stream. So let me just add you guys onto Bluebits. Yeah, sorry if you are a patron and your username is different to what you have on Patreon, if you just let me know your patron name as well when you do it, just so there's no confusion. It's not finding you for some reason. Oh, because I'm adding the wrong name in, that's why. Okay, that should be you added, and patron name is Ollie, and are you using Steps 88? Yeah, you've been added now, you should be able to access it. Okay, well, Steps does that. Sorts out his. Oh, it is Steps 88. Okay, there we go. Steps. It says you don't exist. What's your Flubit name? Yeah, I need your Flubits name for you to connect. So we're going to change the collision. So we started adding the collision to this file, which was here. And the way we were doing it, we were taking the player's sprite position, and we were subtracting the border at the edge of the screen. Is this the collision bit? Yeah, this is it. So we're subtracting the border at the edge of the screen, which was this X offset, which is here, here, and then dividing the X position by 4. We divide by 4, not 8, because we're using half coordinates. So we only have to divide by 4 because we've already halved it once. And then we divide the Y position by 8. But we're going to change that. So what we're going to do, we're going to reset these offsets. So the offsets should be, let's do them in hexadecimal because it's a bit easier. So 24 and 48. Which is 18 and 30 in hex. So that now is the exact edge of the screen here. And we're still going to divide by 4 and divide by 8. But this time we're going to actually add another value. So we're gonna make this routine quite generic. And the way we're going to do that is we're going to have a look at that sprite. We're going to work out how many pixels across it is. And I just closed it down. That was stupid of me. So let's open it up again. I think we said the feet were in the same place in both directions. Not quite. So that's the first thing we need to do. We need the feet to be exactly the same place. So I'm going to shift all of these sprites over by 1, like that. And now the feet are in the same place. Okay, that one is... Wait, which one's running and which one? This one's running, isn't it? Let's have a look. Yeah, so this is a run animation. Let's import that down here. Oh, I've got a bit of a flicker going on. What's that about? I think I've only shifted one of them over. There we go. Yeah, there we go. Right. Now our feet are in the same place all the time. When he jumps a little bit during his run, that's fine. This is going to be our kind of standing still frame anyway, so this is the one we're most bothered about. As long as the feet match on those, we're fine. I'm actually gonna, for now, I'm gonna ignore this jumping animation. Actually, no, I'm not. I'm gonna move all these over as well. Okay. Okay, so we've got matching feet in this column. So I noticed actually that some of these frames are the same, so we can do some editing down of these. I think as well with the method that we're going to use, or the method, one of the method ideas that we're going to use for absorbing an enemy means that this sprite is going to probably have 4 or more sets. So the idea I've got, and it completely depends on what everyone else thinks, and whether or not we can create the art for it, is to have the character, when he absorbs an enemy, to grow slightly bigger. So there might be 4, maybe 5 stages of growth. I was talking with Akmifin before actually, and one of the ideas is you eat enemies to get bigger, and as I've said before, you use the weight of your grown self to activate a switch to exit the level. But in 2-player mode, you are kind of in competition, and to exit the level, you both have to stand on the switch, or one of you stands on the switch, the other one stands on your head. So your combined weight opens a switch. But we were thinking it would be really cool if there was a kind of random element to that as well. So when you both stand on the switch, one of you eats the other player. So one of you kind of wins the round by eating the other player. And the bigger you are, the more chance you have of eating the smaller guy. The small guy can still eat the other guy, but it's a much smaller chance. There's a kind of nice mechanic, and I'll add a little bit of kind of excitement and thrill to the 2-player game as well. But we'll talk about that in more detail when we get around to adding that kind of mechanic in. We're quite a way off that yet. Okay, so we want to update this function, so that so at the moment it's just looking for where this pixel is. So this will return wherever this pixel of the collision is, and we can see that if we run the routine. Oh, actually, I need to change because at the moment it's drawing. So this value here, this is my little test function. This is drawing those little squares you could see, and this was drawing the add 81 was adding 2 rows and 1 character across. So now I'm just going to draw exactly in the top corner where it thinks it is, and you'll see a little square slightly offset as I move around. It's quite a way offset actually. That kind of looks wrong. So it should be kind of here. I did draw this little square on this line across the character so we could see it. So let's get that right first. Let's make sure that that's in the correct place because it's not at the moment. Just double check this. Yep, we're taking the X collision and we're using that along with the row. Okay. So something isn't quite right in here. Oh, it's because we're subtracting an X offset of 24 when it's half coordinates. It should be OC, so it should be 12. Now it should be pretty much on that top corner. You can see as soon as the left edge of this line enters a new square, it gets drawn. You see it's right on the very edge pixel of this square. So that's perfect, that's what we want. But now what we want to do is we want to add some configurability into it. So we want to pass in a position within the sprite. So in our case, this foot and that foot, and it return a square. So we need to change this function a little bit. So these are always going to stay constant. And what we need to do is, in this calculation here, we need to add this X value in as well. So we're going to subtract, so before we subtract this offset, we're going to also add a value. And we want to pass that value into this function. So I think the way we can do this, let's think that we could... So we're not doing anything. We'll pass in an X and a Y. So we'll put some notes here. So we'll say X register contains X offset and Y register contains Y offset. How's the live code working? Is it everything working smoothly for you guys? I've never tried this before. This was something I set up yesterday just to kind of see if it works. I never thought of that actually. The stream's going to be a couple of... Well, as long as it stays ahead of the stream and doesn't fall too far behind, that's good. Right, that's the white wine. That's my starter finished. So let's get on to the main course. But last time I had a Casillero del Diablo white wine, and this time I've gone for a red wine. With a chili grape actually, and I've never had this one before, so smells good. Oh, that's nice actually. I'm not going to be able to drink that fast, I'll tell you that. That's quite strong. Blimey. Okay. To be honest, at the end of the last stream, I was struggling so much. My maths just went completely out of the window. Yeah, red is dangerous with coding. Yeah, I tend to only really drink white wine when I code, but I really enjoyed the white Casillero del Diablo last time. That I really wanted to try the red as well. I do like a red wine. Okay, so we know that we're going to pass in the X and Y here, so we need to store them just while we do this, and we've got exactly the perfect thing for this. So one thing I like to do in Sublime, I'm sure you can do this in other IDEs as well. In fact, I know you can do it in VS Code because I do it myself at work, is I go to View, Layout, Columns, and create 2 columns. And then I can put stuff like the 0-page file in here so I can see it and see what I might need to add. So I kind of use a second pane for stuff I need to reference. So in fact, while I'm here, I might as well put the Vic one in there as well. Where's that gone? Libs. And the tables as well. Oops. Double click them so they actually stay in there. And that way I can just quickly kind of go, okay, I need to know the name of the table. I need to know the Vic label. So it's a very nice way to do that. That's not going to happen for you live through Flubits. You'll have to set that up yourself. You will see updates, of course, but your Flubits is essentially giving you live access to the folder. How you view that folder is entirely down to you. Okay, so these temporary variables, they're only ever going to be used within a function. Once the function exits, they can be reused again. I never want to use these in a way that has to be passed from function to function to function. So I'm going to use temp1 and temp2 to store these values. But what I'm going to do is I'm going to label them. I'm going to give them aliases up here. I'm going to put that down there actually. And so I'm going to call this... I'm going to change the name of that to border offset. I'm going to put that in here, and this in here, and then I'm going to call this X sprite offset, or X pixel offset actually, because this is, we're looking at a very specific pixel within the sprite. And I'm going to point that to there. And so what this allows me to do is then use temp1 and temp2, but with a label that actually means something. Because if you start just putting temp1 and temp2 throughout the code, it will get really difficult to understand what's going on. This tool is very impressive. Yeah, it is. I from what little I saw of it, it looked really, really useful. And I like the fact that it was cross-platform as well, because I know there's people using VS Code, there's people using Atom, and I'm sure others as well. There's plenty of IDEs out there, so it seemed like the only one that was truly cross-platform, cross-IDE. Okay, so the first thing we're going to do before we start any of this code is we're going to store our X and Y values. Pixel offset. No, store. Yeah, that's right. Store X in X pixel offset. Store Y in Y pixel offset. There we go. So now we've got those values, and that means down here where we started doing the addition, we can just do X pixel offset. Now, we should probably put a note here actually. That it's a half value, because we're dealing with X in half coordinates. We need to also deal with any offsets in half coordinates, so we had to do it here. We'll have to do it with this value when we pass it in as well, so we need to make note of that when we actually use this. Okay, so we're adding the pixel offset, and then we're doing all our subtraction stuff and getting the new collision, and we need to do the same with the Y as well. So where's the Y? Here we go. We load it. So before we do this subtraction, we just need to add. I mean, we could do it after that as well. It doesn't really matter which order we do this in. Just like maths, any subtraction you do, an addition, that can happen in either order. It's only when you start using brackets that it becomes a problem. That's offset. That should be offset. There we go. Cool. So what this is doing, this is taking our pixel offset that we're going to pass in an X and Y, and it's going to set these two values here in collision X and Y to be the X and Y position of screen coordinates of this foot here, or whatever pixel offset we put. I'm going to change this, so instead of instead of storing it in collision X, I'm just going to transfer it to X. So you're going to pass in an X and a Y, and you're going to receive an X and a Y, and then it's down to you to do what you want with it, which we'll be probably using this. We're probably going to change this a little bit. So for now, I'm just going to comment that out for now because we're not using it, just so I know I can delete it later on. So cool. So this isn't destroying the X again anywhere here, so that's fine, and it's not destroying the Y. Cool. So now we should be able to perform pretty much the same operation. We do get player collisions here, but I will re-enable this because for now, just for this temporary measure, this is fine. But instead, what we do first, before we get the collisions, we're gonna do not that. Oh yeah, it is going to be a number. Okay, and we need to count how many pixels across it is. So it's 3 pixels across, but it starts here, so it's actually 1, 2. So this is 2. So we're going to add half of that, which is 1. And likewise, this is 21 pixels down, but it starts at 0, so this is 20. We don't have to half this, so we're just going to put 20 in there. And then when we come out, we'll just store X in collision X, store Y, collision Y. There we go. Yes, you do. So I tend to use it liberally at first, and then when I'm looking to optimize, I will go through. You can spend a bit of time and work it out, but you'll notice here that when I do this comparison, I'm comparing if the player is within the border or not, and when I do that comparison, it either sets the flag or clears the flag. So at this point, I don't actually know what it is, so I have to clear it because it could be either. And it's the same down here. So in this case, it's necessary. Likewise, this is necessary because this is likely not going to set the carry flag. So again, it's an unknown. Yeah, as Dr. Miz said, it's good practice to use it for safety's sake, because it's very easy to think that the carry flag is going to be clear or set and not realize that actually there's a comparison somewhere, or there's some kind of branch that's broken that. So it's better to use it and then try and remove them later when you're optimizing the code. It's only 1 byte and it's only 2 cycles, so it's not too bad. When you're writing very optimal code, you will kind of scour over it and you will really kind of look at how you can do it. I mean, if this was in a loop, for instance, that painted every character on this screen, then that's a lot of characters, like 800 characters, and 800 of those accounts to 1600 cycles. That's a couple of lines. That's like 24, 25 lines. So it's a good idea to put them in and only start taking them out when you're looking to optimize code. Okay, so what have we done? So we've changed this now, so it takes an X and a Y. This is our offset for the pixel into the sprite, and then we're storing it back in the positions that we had before. And then we've got this kind of temporary thing here, which is just kind of drawing those squares on the screen. So this is kind of throwaway code. In fact, I'm going to write a little thing here, temporary debug code. And I'm just going to underline it at the bottom here, just so it's obvious that this isn't code we want to stick around. We want to throw this away eventually. Oh god, it's getting quite gassy, that stuff, even though it's not fizzy at all. There's my smoke. I'm still on the same CBD oil, and for some reason my vape pen has decided to start being a pain. Getting really hard to turn it on. I've got to keep unplugging it and plugging it back in again. Okay, while I do that, let's give it a run. And see, this is the beauty of Flubits. A few of you could have already run this. And so now what we should see is those squares appear, but in relation to my foot. Although it's appearing one below, it should be a bit higher. So I might need to tweak the border offsets a little bit, but you can see there, if I just... Oh, no, it's still... I need to tweak the border offsets, I think, a little bit. But it's definitely almost there, so let's tweak that a little bit. So what do I need to subtract more or subtract less? I probably need to subtract... I'm gonna... Well, let's go one way and see if it's wrong. I'm thinking I need to subtract more. But I have a funny feeling it's going to be less. The reason why it's the floor, the square is there is because we're clipping... whenever the player goes into this border, we're assuming its top corner is just locked to this position. So his foot, if you imagine his head up there, you know, his foot is going to be down there. So yeah, I think it should have been the other way. All right. I can't seem to get my vape pen working. Oh, there we go. Oh, no, it's not. Yeah, so as soon as that pixel... So he's still in the other square. One tap and I should get... Yeah, there we go. So it's spot on that bottom foot now. Vertically it's not, so we need to look at that next. So he's not in that bottom square, but it's appeared. So let's go and change that. And that means this needs to go down a bit, so let's just knock this down 1 pixel. And for you guys on Flubits, are you able to compile? Is F7 working alright for you? That's kind of important. That's one of the selling points of this, I guess. That's still not quite right, still a bit early. It's working. That's brilliant. So that's really cool. This is a really cool way for you to kind of see. And so one of the streams we did some debugging, didn't we? And it would have been really, really painful for you guys with coding experience to watch and not have the ability to kind of change things. So now you have that ability. That needs to go up, not down. So, you know, while I'm off smoking, you guys can actually look through the code at your own pace without having to get me to leave it on screen or anything. Cool. That seems to be quite good now. So you'll see as I move down... Actually... He seemed to... Oh, because he was at the top. Okay, so let me come down to here. So he's right on the bottom of that square. As I tap down, I'm just going to slow it down a little bit, actually, and then it will... Yep, straight away. And the same as I move across. Straight away. There we go. Excellent. That's a really good point, actually. I think this is going to be a 2-player game. So if you guys want to come up with some kind of good duo names... I mean, think of Bubble Bobble, Bubble and Bob. The game is named Bubble Bobble, so no such file or directory. Jeff and Joff. Well, yeah, something like that. Dom and Dog, very good. But this is not working. I'm not sure what that error is. If you're still having problems after the stream, I can help you with it then, or if somebody can help Amok with it now, that'd be good. But yeah, while we're on stream, it's not going to be easy to do these kind of live fixes for things like that. But it is definitely something to do with your local setup, I would guess. Cool. So that looks good. So now we've got the left foot. So what we're going to do is we're going to... So we can't use temp because we're jumping to another function. So the other thing with these temp values is if you're using them, you can't jump to any other functions before you need them, because that other function could also be using them. So you need to kind of keep them separated. If you do need to store a value, that you would create a separate variable for that. You could create a variable, you know, around here somewhere if you needed to create a value and then jump to functions. So there's a lot of jumping going on here. But what I'm going to do instead is I'm going to create two sets of collision variables, one for each foot. We'll probably call them collision foot x1 and collision foot x2 at some point. But for now, we'll just call them this. I'll store that there and there. And then we're basically going to do the same thing again. And we're going to... in fact, this is a perfect opportunity to kind of rejig this a little bit. So what we've got here is a very generic kind of collision function that just takes a sprite position. Actually, no, it takes the player position, doesn't it? Okay. Let's rename this slightly. We're going to call it get collision point. And put that here. We're going to call it here. Actually, we're going to call get collisions and get collision point here, and get collisions is now going to be a function in here. So get collisions is just going to call this function over and over again, and get all the collision points around the player. We can make this more generic later on. And the usually set up 16 8-bit 0-page temps and 8-word 0-page, so there's always plenty to go out. Yeah, I tend to set... it's usually about 10 I actually set up, but I set 20 in total, so I have 10 that can be used by normal functions and then 10 that can be used by IRQs, by the interrupts. Because an interrupt can happen at any point, you want the temporary variables that they use to be unique to interrupts. Otherwise you can get clash between your normal function temporaries and your interrupt temporaries. It was really interesting actually. I was expecting to see the 0-page completely full and it wasn't. I'd be interested to look. I think at some point we'll have to have a look at Creatures 2 and Mayhem, because I'm be very surprised if they didn't use more. I think one of the reasons they didn't need to is because they used that VSP scrolling trick, so they had lots of free cycle time to do what they wanted, because they weren't having to do a copy every frame or every couple of frames. So, you know, I mean, one of the main advantages of using the 0-page is for speed, really. So Hayes is playing Creatures 2. Yeah, I did see a little bit actually, just because I logged on, I was hosting Hayes, so I saw that he was playing that. How's he doing? Because he wasn't doing too great on Creatures 1. Is he trying to speedrun it, or is he just playing it? Let's get this other sprite. So we're looking at this one here. So it's 20 down again. 1, 2. This is kind of in the third spot. Cool. So now we're getting 2 locations. We're getting both of these locations. So now what I'm going to do is change this. I'm going to create a little temporary... Ah, thanks Dom for the host. Just tries to complete it for now. Yeah. He wasn't doing very well on that speedrun. He wasn't doing very well at all on that. But it just takes practice. He's doing better than I could ever do, so... now we don't actually need to use... it's a very good point, actually. We don't actually need to do any crazy addition because we're getting the exact pixels, so y is always going to be 0 in this case. Well, y is always going to be that value, so that simplifies a lot. So we've simplified this a little bit, but this is only temporary code, so... So we're using another temp variable here, but there's no other jump to subroutines here. So this way we're just going to try and draw the 2 squares underneath the foot. Press button to win cheat implemented. Oh, we'll have to do that on one of the next hacking streams. Is just find the game complete routine, and just have it immediately fire when you press start. Basically, just completely skip the game completely, and then change the intro to just say press fire to win. We should do that. That would be funny. Okay, so we're doing the same thing as here, but we're using y2 and x2. So now it's going to draw 2 squares. The only problem we've got here is it's going to, every time we do this, it's also going to keep the last one. So what I'm going to very temporarily do, just for this, is I'm going to always draw them out. It's going to flicker like crazy, this, but I'm always going to draw the map every frame. It's going to flicker like mad, but at least it's going to clear that block from underneath us. So now we can see the 2 blocks, and that seems pretty good. You know, if I'm stood on 1 block there, and that's perfect. Stood on 2, stood on 1. That's kind of what we want. So with that in place now, we can now check what is under our feet. And so that means we can start implementing some gravity. So at the moment, when we go off the bottom of the screen, what happens? We just loop around, I think, don't we? Yeah, we just loop around to the top. Okay, cool. So we can add gravity because we'll just fall and land on there. So we'll start by adding the gravity. I'll show you how we do that. So first of all, let's just clear up some of this code. So let's disable that draw map because we don't need that anymore. Just get rid of that. That was just so I could see the squares clear. This temporary debug code, we don't need that either. Just gonna leave it like that because we may use this again for doing other bits of collision around. So for now we'll leave that there. So what we're doing, we're controlling the player. So we're accepting joystick input and updating the player's position. We're drawing the player, which means moving its sprite to its new position, and then we're getting any collisions at that point. So we might need to jiggle this around a little bit. So I think the first thing we need to do is we need to block the player from moving if it's colliding below. So let's do the player control last. So we draw the player and then we get the controls for the next frame. So let's just make sure that doesn't feel laggy. Sometimes it can feel a bit weird when you do things at the end of the frame instead. That seems fine. So the first thing we want it to do is when we move down, we want it to stop. So we want to make sure that if we press down on the joystick, we're gonna stop at that. It's not something. It's a control we'll be removing in a minute because obviously pulling down is not going to move us down. Pushing up is going to initiate a jump, but pulling down isn't going to do anything. But for now, let's do a check here to make sure you can't. So this is the bit that's moving us down, and we check the joystick here. So before we even check the joystick, what we can do is we can check. Actually, so we need to grab those 2 values. So we're going to create another function. And this time where should we put it? Let's create. I'm gonna create a utils folder in here, I think, and that's gonna contain. Why didn't that create it? Where did that go? I need to refresh. Where's my refresh? There we go. Yeah. And in here, I'm gonna create utils code block like that. I'm gonna save that as utils.asm. This is where we'll move our kind of sprite to character lookup at some point. So this kind of, what was it called, get collision point or something, we'll move that in there eventually. For now we'll leave it in here because it is tied to the player, but we'll factor that out at some point and make this, we'll probably pass a sprite number in or something, and it will use that sprite number. So you would pass, you know, a register as sprite number, but for now we'll leave it in here. But what we will put in here is a function that will return the contents of this location, basically. So basically the code that we're doing, where was it? It was in the start, wasn't it? Some of this code. So let's copy one of these. Let's create get character at, and we'll pass in. I think if we store everything in pairs like this, how can I do this? Are we aiming to fit this all in 16K? Ideally, yes, but that will be 16K when it's compressed. So as long as we're clever about how we arrange memory, about how we use our assets, so things like sprites. So one thing I mentioned today was these sprites, it's pointless as storing them in both directions because they're exactly the same. We can mirror them in code quite easily. So we'll write some code that do the mirroring, especially if we've got like 4 sets of sprites for different sizes. It makes sense to do that. We'll do some reuse as well. So this is a jump animation, but you can see the first 2 frames are the same. In fact, the first 3 are the same almost. It's just he starts moving up, so it might be that we can trim this down. We'll probably trim the walk cycle down. It's 8 frames at the moment, so we'll probably trim it down to 4 or 5 or something. 4 seems normal. I mean, Mario on the NES uses 4 frames for its walk cycle, and that's perfectly fine as well. Hey Farai, hey Colt, welcome to the stream. Yeah, I think they'll pack fine as well because there'll be a lot of dead space. And in the original file, we've got some small versions already. So we've got like a small character here, which could be, you know, stage 1, stage 2, and then it just needs to be a little bit bigger and so on. So we've already got 2 sets of the frames already. We might need to trim down the number of sprites that are in them, but you know, we've got. Where's the play button gone? There it is. You know, we've got a small version, we've got a big version. Although the only thing that seems to have changed size between these 2 is the head. But it could just be the head. I mean, if we want to make it really simple, it could literally just be his head gets bigger. It really doesn't matter how we go about it. It depends entirely on what people come up with. I'm going to give it a go as well, but I advise anybody to download these assets from GitHub, have a play around with them, post them in the asset share, and see what we can come up with. But yeah, I think if we can maybe aim to do this kind of absorb thing, it will be really cool. It'll be quite a unique feature as well. There aren't many games that do that. He needs a big mouth if he's eating everything. Yeah, actually, a big head might work perfectly. It might be just enough. for it to still look correct in that he's eating things and getting bigger, but it's just not his body getting bigger. But I don't know. We can try out a few different styles and see which one looks the best. For now, we're just going to get him moving around. Okay, so we want to write a function that gets a character. So given an X and a Y, it needs to return a character. So we'll do the same again. We'll have X register equals X char position. It's always good to write if you're going to pass registers as parameters, it's always good to write a little comment at the top just so you know what you're supposed to be passing in. Okay, so we're getting the character at there, and so we basically need this code, but we're not using the collision lookup. We've already got the Y because it's passed in, so we don't need that. We do need to use the table. Oh, wait a minute. It's using the temp. It's using these temp variables as an address, so we do need to create that label. We've already got the Y, so we're getting the screen row correct. We store the screen row least significant bit in temp 1. Store the screen row most significant byte in temp 2, so temp 1 plus 1. And now we need to do this, but this value is actually in the X register, and we need to get it into the Y register. Now there isn't a way of doing, you can't do this, unfortunately, but what you can do is you can transfer it to the accumulator, and then you can transfer it to Y. It takes 2 extra cycles and 1 extra bit, 1 extra byte, but it does the same thing. And then we're not actually storing the value, we want to read the value in that position and return. Cool, so now we know what character is in that position, and so what we can do is to prove that, we'll leave all that there for now. Get collision, so get character at, okay, so collision should be after the player control. So we draw the player, then we get any control, and we get any collisions, and then we can load X with X1 and Y with Y1. We can jump to our new utils function, and then we can store that somewhere. So at the moment we're using the majority of the screen, so we'll just store it on the bottom row. So if we store it at screen, do we have screen RAM set up? We should have it set up somewhere in assets, probably. Where is it? Where's assets? There it is. Oh no, in source maps. There we go. Assets, screen RAM, yeah, okay. So that's screen RAM plus row 23 or something, and just move it 5 in or something. 23, let's do it on the very bottom row, there we go. So now it'll get whatever character's under my left foot, and it will draw it in the bottom corner of the screen. Oh, we got an error. What's the error? Oh, because I need to import utils. So now I've created a new library. I need to import here. Actually, libs might get used again. I'm going to leave it in utils for now, because utils tends to fill up with things that are specific to your game. We can always move some stuff out into a library if we think it's useful. Oh, what am I doing? Utils. Utils. There we go. Catch up with chat. You pilot looking at the material data in the char map. Yep, that's the next step. So at the moment, what this is going to do... Why is that not working? Can't open file... Oh, because it's not back a folder. It's... Where are we? We're in source. That's there. There we go. It's just a path folder. So if you get this error, it just means your path is wrong. So you just need to check where it is. So you see now we've got this character down here. This is whatever is deemed as being under the left foot. It won't be coloured correctly because we're not using colour RAM from here. We're just getting the screen data. But if we move him around, you'll see as he goes under here. Yep. So you see he's getting exactly what's under his foot. But that's not enough because what we need to know, this doesn't tell us if that is solid or not. So what we need to do is we need to add some kind of some extra data to our map, and the way we do that is with materials. First of all though, I'm going to have a quick cigarette because this vape is absolutely useless and it's not working. I'm going to top my wine up and then we'll start looking at materials. So back in 5 minutes guys, be right back. Cool, and I'm back. Getting quicker at that. Okay, so where were we? Yeah, so we had the... We'd know what character is underneath the player, under his left foot, but we don't know if it's solid or not. And so to do that, we need to add some extra data. And the way to do that in Charpad, is through these materials here. So when we store the color data, when we export the color data, actually it shows really weird. Let me look at it in a hex editor. You probably can't see that very well. Let me try opening it anyway. Let's go to my folder, my OneDrive. In a weird place now because of flew bits, but so this is the file that gets exported, and you can see it because they're colours. It's only using the lower nibble, the lower 4 bits of each one. So there's a 0 in front of every one of these, and what Charpad lets you do is it lets you store a value in there, what you want. So what we're going to do is we're going to create 4 flags, one for each bit, that indicate various things. So we're gonna let's put it in maybe this should be in I don't know where to put this. Let's put it in new utils. I think for now we can always move it. So we're just going to create some labels, and these are going to be our collision flags, and we're going to have we're going to call them collision, and we're going to start with solid, and solid will be the first bit, and that means we can create a few different things. We can have up to 4 different collision things. Let's put some examples of what we might have here. So we could have collision death, so that could be spikes, water, things like that. Solid, solid 2, solid floor maybe. So if you want to jump up through platforms, you tend to have 2 flags. So you'll have a flag that says it's solid as a floor, and then another flag which says it's solid as a ceiling or a wall. So you might have a solid 2 like that. You might want to call it something else. And then you could have like ladder, for instance. And you can combine these as well. So you, well, you wouldn't combine any of these, I guess. But for now, we'll just have collision solid because that's the only one we're interested in. So in .cosmos 2, I have about 8 different flags. I think six, either 6 or 8. I can't remember. So I can't use this method, unfortunately. I have to use a different lookup table for it. But for our game, it should be more than enough. So what we'll do is we know bit 1 is going to be our solid. So all we need to do is whenever we want an item to be solid. Let's open our project. Oh god, I've got to set these folders up ahead of time so I don't have to keep doing this. There we go. So all we need to do is on these characters here, just make them a bit bigger, is determine which ones are solid and set the material value to 1. So that bit 1 of the higher nibble will be set. So what we'll do is we'll just set everything in this kind of block, so that these 3 characters, we'll leave the ladder, we'll just do these 3 characters, so all 3 of those will be solid. So where was it gone? There it is. So we want that, that, and that. So set that to 1, that to 1, that to 1. There we go. And then all we have to do, we'll save the project again just to make sure that it's saved that data, and then just export the color table again. So it's the character set attributes. And now when we look at it in here, what we should see is some of them have a 1 next to me. It's probably very hard to see that on the stream, but I can't make this bigger, unfortunately. I think that's just a search button. I don't think that's, yeah, it's just a search. But yeah, now those 3 elements now have a 1 in front of them. Now, because the Vic chip only looks at the bottom 4 nibbles, the bottom nibble, the bottom 4 bits, when it inputs the color, we don't need to change anything in our map drawer. Even though we're drawing the color 1, 5, it's still, the Vic will still see it as 5. So that's kind of handy. We don't have to change anything there, but we do need to do some testing of bits when we want to check if something's solid underneath us. So what I'm going to do now is I'm going to do a little test. So this was where we were getting our collision and we were storing the value here. Instead, what I'm going to do is I'm going to transfer that value to our X register, and then I'm going to grab the color at that location. So I'm going to load the assets file in here so I can see what we called it. Char colors, there we go. So we're going to load whatever color is at that location, and because we're only interested in the upper 4 bytes, we'll just AND it with, and we only get the upper 4, and then we can shift that to the right. I mean, we won't need to do this. We can just use the upper bytes to do it. In fact, if we go in our utils file and change this, so now it's if that upper bit is set, but just for display purposes, I'm just going to shift it to the right, and so now we'll have either 0 or 1 in the accumulator, and I'm going to store that at Vic color RAM, and I'm going to store that. I think our screen actually has, yeah, we have a character here, so I can just change the color of this here depending on if something is solid or not. So I'm just going to store it there like that. There we go. So now what we will see when we run this is this square will be black when we're not on something solid and white when we are on something solid. So there you go, it's black, it's black, it's black, and then as we hit that it turns white, and so there we go, we've got some solidity. Problem is now though, we're on a solid there, but if we just nudge over, because 1 foot is off, and we're only checking that one, it now thinks we're not on solid ground. So the way we do that is once we've got this value here, we're going to just store it in the temporary for now. Can I store it in there? Collision 1. Yep, that's fine. It's not been used at that point. That's fine. We're not going to use it again. Actually, we're going to do a jump here, so that's not a good idea to store that there. So instead, what I'm going to do is I'm going to... Oh, this is awkward. So I'm going to come down here I'm just going to create a byte down here just to use. This is only temporary. We're going to have a different function to do this. I'm going to call this doesn't really matter what I call it, to be honest. It's going to get moved anyway. I'm just going to store that byte in that location, and then I'm going to do this again, but this time I'm going to do it with our other foot. And so I'll leave that down there. So at this point, at this point our accumulator contains what's in the right foot. So all we need to do is OR it with the contents of this foot. So now if either foot or both feet is on ground, it will think we're on solid ground. Why is that not? Oh, so I need to close that. So same again, it's black, but this time if I nudge over, I'm still on solid ground. It says I'm not there actually, but my one foot still is, but maybe we need to tweak that value a little bit. But you can see it's definitely a lot better now. It needs, I think we need to tweak that second value. So the value for this foot needs moving a little bit. So that was up in the player function, it was here. So this value here, I'm going to change that to 4. Just see if that works. Yep, there we go, perfect. So you can see as soon as I'm on solid ground with one foot, it thinks I'm on solid ground. The moment I leave the ground, same with the other way as well. Let's just check that. Yep, it's fine. So that's perfect. That's pixel perfect now. So, okay, we've got whether or not we've collided with that, whether we're on the floor. So what we'll do now is we'll actually move this code into the player collision stuff. So this is all this block of code here is what is basically part of our player collisions. So we'll go into get collisions, which is this bit here. We'll put a little thing here to say get floor collisions for each foot, so we know what it's doing, and then we can put that we can probably separate this a little bit, so we get one foot, which is here. Then we get the character at that location. We don't need to store it. Ooh, I'll do that. So you see we're simplifying it, reducing the number of bytes by piling it all into one function. Where did I just pull that from? There we go. Right, let's try and separate the concerns a little bit. So that belongs to that, and this belongs to this. So these stores and loads can disappear because X and Y is already set. So now we're just getting that character, and we can store that somewhere else this time. So what we're going to do is we're going to create a byte in here. We'll call it player floor collision. And that's where we'll store that. So this is getting the character, it's working out from this offset into the sprite, it's getting the collision point, converting it into a character, and then getting the collision, the collision color at that location. We will AND it with that. We probably don't need to, because we're not really concerned with the lower 4 bytes, but just to make it easier to read, we'll get rid of the lower 4 bits. I keep saying bytes, I mean bits. The lower nibble. So for those who don't know, a nibble is the the lower 4 bits of a byte. So it's this in hexadecimal. It's the lower number. That's called the lower nibble, and that's called the higher nibble. That bit. And so we do the same for the right foot. We can simplify this, so we don't need to do that. So that removes quite a few bytes there. It's like 8 bytes gone. Same again. We get the character at that position. We do that. We AND it with F0 again to get rid of the lower nibble. In fact, we can simplify this again. Yeah, so we'll get rid of that. And we'll get rid of that. We'll OR them together. And then we'll do that. Oops. Then we'll do that. So we're only doing it once. And then we'll store it back in player floor collision. So, I don't know how well you've followed that, but basically what we're doing now is we've got rid of the code from here, so we can get rid of this now. We don't need that. And we've kind of refactored it a little bit to do it all in the player collision. So when we call get collisions, the end result will be the collision data underneath the feet will be stored in here. And this combines the two. So if we do have in fact, this should probably be in the player, I think. Let's move it to the player for now. We can always move it somewhere else later. If we did have collision death here, which would be the next byte, and one foot was on spikes and the other one was on ground, we'd still die because it would say we're on solid but also on spikes. So it would combine the two, it would OR the two together, so we'd end up with that. So now we can do some comparisons. Cool. So we'll test this again. So we'll leave this functionality in here. We don't need that anymore. This is just debug because this is just showing us. I like to just wrap debug blocks like that just so I can see where they are. I can delete them later or comment them out. This is handy because now I can just quickly make sure that this function has worked correctly. So make sure we're still calling it get collisions. We are. Cool. And we've got the same functionality, so yeah, everything works exactly as it did before. But now what we have is we now have this variable set. This memory location is set after every. Why is it not scroll? It's really bad at scrolling this sometimes. This value will be set after every get collision call. In those creatures to end level bosses must be 16 sprites at least. Yeah, they're huge. They're really good and quite smooth as well. There's a really nice split going on. But yeah, as Andy says, you can see it sometimes. But yeah, I mean they are huge. Especially the big one where you're kicking the little bugs into the vacuum cleaner is amazing. That thing is huge. Yeah, it could be bad lines actually, because if you've got sprites crossing bad lines, and you're trying to multiplex them in a tight formation like that, it can cause problems. But to be honest, once you've drawn a sprite, once you start drawing it, you can set the next one up, and especially if they're aligned in a block like that. I mean, they'll be aligned in a grid. They won't be any weird X offsets. They'll all be aligned perfect X. So really, as soon as you start drawing a sprite, you can kind of set the next sprite up. So it shouldn't flicker that much. But yeah, bad lines can still cause problems because there's still going to be a little bit of code you have to do on that line. Are you not getting the collision data? Maybe you're not getting the collision data, Andy. If you check the cols.bin file, it should look like this if you open it in Sublime. You see this one here, one here, and one here. You had to open it. Okay, yeah, maybe. So I think with a binary file like this, maybe you have to open it first for it to sync, because it's a binary file. So it's working though now, yeah. This wine is very strong. I need to take my time with this. I can really feel this going. There's not going to be 2 bottles tonight, that's for sure. Although I'm on my 3rd glass in an hour and a half, so I'm still going at some rate, that's for sure. Okay, so now we've got... You just get a black screen. Ah, interesting. You don't get anything at all. So one thing you can do is if you look in the source folder here, whenever I compile it, this bin folder will get a new start.prg. You might just be able to find this folder on your machine and drop this start.prg into Vice, and you might be able to see it just to see if it's working correctly. Otherwise, yeah, you might just need to open some of the files and update them. Yeah, my maths goes downhill very quickly after wine, so I do need to take my time a little bit. I've got a little desk fan as well now, so I'm going to turn that on and hopefully it's not going to make a noise on my mic. Just helps me keep cool a little bit. A very tiny one. So let me know if you hear a weird buzzing on the mic. Hopefully you won't. I think I'm a bit louder than it anyway. Okay, so let's start by looking at the joystick stuff. Now we've got that routine in, we want to just change the joystick control. Any idea why my colours are different from yours? Not sure. Again, it could be that you need to open all these files first. Lava is blue. Oh, that would imply lava is blue. What lava? Oh, you mean this stuff? That's grass, I think. I think it's supposed to be grass. I would hope it's supposed to be grass. Okay, so maybe we need to look at, before the next stream, we'll take a look at why this is happening. So probably tomorrow off stream, if one of you is around who's having problems with this, we can kind of work through it together and try and figure out what the issues are. Because it's new technology to me as well. I'm not entirely sure how it works. But I would have thought that the binary files would have updated at the same time, but I guess not. Maybe because I'm not doing it in my IDE. Maybe if I open them here. Like, does that update for you maybe now? Anyway, let's add this into the player control. We can look at that off stream at some point. So this is where we want to do our check. We just want to we're going to remove this eventually because pulling down on the joystick is going to do nothing, or at least for now it's going to do nothing. Maybe it initiates the absorb animation. I'm not sure yet. We will worry about that later. But what it's certainly not going to do is move us down the screen. But we're just going to use this just to test that our collision stuff is working. So what we'll do is we'll just load the contents of I forgot what I called it now, player floor collision, and we will AND it with our collision flag, our collision solid, which is a constant value, it's not an address. And if that returns anything other than 0, so if the end result of this is anything other than 0, then we've hit something solid. So if it's not 0, then we can skip this down. And that should be it. That should be all we need now to prevent ourselves from walking through things. So now, yeah, there we go. And now I can't go through that, but I should be able to go down there. Cool. So we've got very, very basic collision. Now you'll notice I can walk in sideways like this. We obviously have no side-to-side collision yet, so that's a bit of a problem. You'll also notice when I land, I'm actually 2 pixels in, and that's because I'm moving it 2 pixels per frame anyway, and it's not going to stop me from moving until it thinks I'm over an object. So at the moment it's 2 pixels in. That's not a problem because it kind of looks all right on this, but when it is going to be a problem is when we do a jump. So when we do a jump, we're gonna do a jump using a sine curve. So we'll start moving at 1 pixel, then 2, then 3, then 4, then 5. So we move faster up, and then when we reach the peak, we'll fall, starting with we'll jump 5, 4, 3, 2, 1, or something like that. And then when we reach the peak, we'll fall 1, 2, 3, 4, 5, and we'll reach a terminal velocity of say 5 pixels per frame. But what that may mean we do is we kind of go a little bit through the block. So that means we're going to have to snap the value, but I'll show you that when we get to that. Yeah, I mean it's not going to be a perfect sine, but 1, 2, 3, 4, 5, and then back again is pretty much. I call it a sinus curve because it's not a straightforward linear curve. It's some kind of parabolic curve. Sinus is the word I use for all these things. Cool, so we've got some collision in here. We'll leave that little debug character in the corner. We'll get rid of it eventually, but we can leave it there for now, just so we know that things are behaving as we want it to behave. And so what we'll do now is we'll get rid of the down movement completely, and instead what we'll do is we'll add jump and fall. So the way I like to do this is in player control, or just after player control. We'll create another routine called jump and fall. And the way we do this is really simple. So all our collision is there. So where's our control? Where's our control gone? There's our player control. So we've got rid of the down, so all we need to do is create a jump and fall. And the reason I put both in there is because you can only do one of these at a time. You can't do both. So I have a function which, depending on which way you're going, whether you're jumping or falling, it will apply some values. So the first thing to do is we create a table, and the table we'll call it a jump table. Actually, we'll call it jump and fall table. I'll explain why in a minute. And we're just going to put some starting values in here. So when we jump, we'll start with 4. We'll move up 4 twice, then 3 twice, then 2 twice, and then 1 twice. We can tweak this table later, but this is a good way to start with some very basic. Oh, I shouldn't have done it that way. I keep forgetting this is. Keep it on stream. There we go. This is a simple way to do it. Now, I want to know when I get to the end of this table, and this table I could change the number of values in this. So what I like to do is I like to close the table with another label, and I just put a double underscore in front of it. I'll show you why I do that in a minute. I'm going to move some of our so we've got these 2 bytes up here, so I'm going to move this up there as well. I want to keep all our variables together, so when we're looking for the memory addresses for these things, they'll all be in the same place. We're not having to go look all over the place. And I'm going to create jump index, and that's going to be 0. to begin with. I'm going to create a variable called player state, which is also going to be 0. This is really bad for scrolling. For some reason the scrolling's all over the place. Can't actually scroll properly. And then I'm going to create some player states here. So we're going to have state jump. And so what we're going to do is we're going to use this byte to determine what state the player is in. So if this byte is 0, it means there's nothing happening. And then we're going to use individual bits for jumping, for falling, and we'll use it for other things as well. So we may have some kind of animation state for, I don't know, eating the characters, for swinging your weapon. We may actually add, we could move player floor collision into here as a single byte, so we know if we're on the floor or not. For now we'll keep it separate, but we may want to combine it. So yeah, I like to keep a player state like this. The reason for this is if you're jumping, you shouldn't be falling. So you can only be doing one of these at a time. Likewise, if you get to the top of your jump and the jump stops, then you should immediately be setting your state to fall. Will there be projectiles in the game? We haven't decided yet, to be honest, Steps. I don't see any particular need to, but I would like to do some character sprite stuff at some point. So maybe if we don't have bullets or enemy bullets, then we'll add some kind of effect that uses character sprites, because I think it's a useful technique for you guys to learn. I think somebody, it might have been you, Steps, actually, that asked, or it might have been Foray that asked about character animations as well. And I definitely want to cover character animations at some point. So when we get around to doing those things, we'll go through them in detail. But today is collision day. Today we get things to collide. Okay, so what do we need to do? We need to set this player state that we've now got up here based on jumping or falling. So let's start by just implementing falling. We can do the jumping next. So we need to load the collision variable in here. We need to do the same check that we did in here. So it's basically this code. We need to do that down here. And what I'm going to do is I'm going to create... No, that's fine. Okay. So, if we are on the floor, then we need to set the value in player state, and we need to turn on the... No, sorry. If blah blah blah. If we are on the floor, we do nothing. If we aren't on the floor, wait, is that right? Player collision. If yeah, that's right. If we're on the floor, we do nothing. Otherwise, we turn the fall flag on. And what I'd like to do first of all, before we do anything, is clear the flags that we're going to mess with. And the way to do that is you take 255 and then you take off the flags that you're going to be changing. So we always start with these flags cleared. So that will clear the fall flag, and then this will set it if we're not on the floor. So this is set flags. We won't need down later to go down ladders. Maybe if we have ladders, we may not do. We may just have jumping up and down. Yeah. You can do math there with immediates. Yeah. So this is This just lets you kind of pre-compile this value. It's very good. I mean, I use this all over the place. I use and 255 minus and then a list of states that I want to clear, because it's kind of the opposite of doing this, basically. So this is now setting a flag whether or not we should fall. And so if we're falling, we need to grab a value from this table. So first thing we need to do, if we are falling and the player index is, where is it? Player jump index is at 0. We need to set it to this, so the last value. Because jump is this way, fall is this way. Hi SVT, SVT I'm not even going to try and say that. This is Sublime Text 3. It's a common kind of web dev, and well, it's used for all sorts. I use it for web dev a lot, but you can use it for this as well. Although it seems to have a real problem with me using the mouse wheel to scroll up and down. I can do it in the margin here, and I can do it here, but I can't seem to do it in the middle unless I can do it right at the edge. It seems to be if there's any code anywhere like this here is stopping me. I reckon if I removed some of that, I'd be able to scroll, but for some reason it seems to create a blocker for me doing that, so I just got to scroll down the sides. I think the stream title might be wrong. What's the stream title say? It should say, let's make a... Just check that. Not sure if I can change that from in here, actually. Oh, does it still say creatures? Oh, it really shouldn't. Let me just check that. Can't have that. Oh no, it says let's make a game. You must have some cache or something. Seems to be fine for me. Cool. Yeah, you must just have a cache problem or something. Oh, there you go. You're using Mac. No sympathy. Okay, so we need to check our fall index. Play a jump index even. Oh, thank you for the follow. Who was that? I didn't see who that was. Oh, SVT. Thank you, SVT. I'm just thinking about this jump now. It's the best way of doing this, because if it's 0, then we could... I don't want it to reset every time. Okay, what we need to actually do is, instead of clearing the fall state here, I'm not going to clear the state there. I may clear something else. I'll just leave this here for now, because I might clear something else later. Thank you for the Mac tax bit, Sandy. I feel your pain. I work with Mac all the time at work, and I've grown to like it more than I used to. I definitely hate OS X less than I did 6 or 7 years ago. But I can't say I enjoy it as much as I enjoy Windows. I do like the terminal though. The terminal's a lot better on Mac. You can get a Linux style terminal, but oh, thank you for the bits, Acmafin. 8 bits of fame. You can get a Linux terminal on Windows, but to be honest, it's it's not worth the it's not worth the hassle, to be honest. Your English is much better than my Ukrainian, that's for sure. Okay, so this is where we actually set the state, but what I'm going to do first is if I'm going to I need to compare it with, I need to check if we're already falling. If we're already falling, then we don't need to do anything. So if it's not 0 when I check, then we don't need to do anything. Otherwise, we do need to do something. We need to set the fall. And then we need to set the jump index to the end of the jump array, which I'm going to show you how we calculate in a minute. Player jump index, there we go. So this will ensure that if we're already falling, it doesn't do anything. If we're just starting to fall, then it will start the fall at this position here. Now, this 8 is not right, it's 8, it should actually be 7 looking at this. But what I like to do instead is another calculation. So what I'll do is I'll get this label and I'll take that label away, and that will give me this length here. Is that right? So yeah, it'll give me 1. Yeah, that gives me that length, and then -1, and that should give me this value here. So now I can change this table. I can put as many values as I want in here, and this will always be correct. Oops, where did that go? Okay, so now we are setting the value if we're falling. Okay, so I'm going to change this to not falling, and I'm going to put a label here to say falling. I'm going to call this not falling, and I'm going to put exit falling check here. And so now if we're falling, we're going to do this, and then we're going to jump to the exit falling check, which is ahead. And if we're not falling, then we'll do this clearing the falling state. Cool. So this will now make us fall, or it will initiate the fall. It will set up the index for our fall. And then I guess here we'd have the jump as well in here, but we'll start with the apply fall or jump. Good night. Sleep well. It must be quite late in Ukraine. Are they like 4 hours ahead or so? And these streams are available on YouTube the day after as well. You're following me now, so you should be able to see them. There's links to everything down there, where you can get notifications for all the YouTube updates, and I post it all on Twitter as well. So this is just here, so we can jump to here. So this is where we're going to apply any fall or jump. So we're going to do another check. We will come back over this at some point and do some optimization. There's a lot of kind of loading the same values in. We could probably use the stack or something to make this a bit easier, a bit less code. But for now, this is fine. And we're only concerned about the fall at the moment, so we'll just check. We'll check that we're falling. If we're not falling, as in if this is 0, then we can we'll just do a skip, because that's probably enough. Otherwise, we're going to apply the fall, and the way we're going to do that is we're going to take the value that's in the jump and fall table, index with x. We're going to get x from our is it player jump index? There we go. and we're going to add, so we're going to clear the carry bit, we're going to add our player Y, and then we're going to store it in player Y. So this will work now, but what this will do, it will just move us down at one pixel per second. So let's just see that working, because we've added a lot of code in there, so it makes sense to give it a quick test. Okay, we've got some errors. Okay, state 4, where is that? What line is that on? 219. Oh, we've got a few here. Okay, so if we're not falling, then we jump to not falling. No, wait up. If we're already falling, then we just jump to exit falling check. So like that, yeah. Unknown symbol, because we need to put tables. Yeah. And tables. Oops, still got a bug. Exit falling check. Exit falling check, that should be right. Oh, did I delete it from the... Pay attention to what I'm doing. So at the moment our player is going to be... In fact, you can see it there, he's dropping down. So there we go. And if I go off the edge, he'll move down and hits the floor. So we've got him moving, but he's not following our curve, and that's because we need to actually move the index in that table down a little bit. So let's go and do that. Now we've got the code working. So this is where we apply the value, and then when we're done, this X value is our jump index here. Because we're falling, we just decrease it, and if the value is still positive, then we don't need to do anything. Otherwise, we need to set it to 0. And that just ensures that when we get to the bottom of the table, we just lock here. This is our terminal fall velocity, basically. And then here, we store that in player jump index. Cool. So, I don't know if we covered branch plus and branch minus, but I'll explain very quickly what that does. So we've touched on negative numbers, so any number with bit 7 set, so 128 and above, is deemed a negative number. So you can view it as 128, or you can view it as minus 127 or something, and that's what this is doing. So this is branching if the negative bit is not set, and the opposite is that, which is branch if minus, branch if the negative bit is set. No multiple. There are ways you can divide by 3. I've actually, in Discord, there is a short snippet of code for an approximate divide by 3. Actually, I think that's what Steps has posted to there, actually. Let's have a look. Yeah, there's an approximate divide by 3. It uses a Taylor series to approximate it. But you can do it accurately as well. It just takes a lot of cycles to do. Generally, if you need to divide by something by 3, you probably need to rethink your code. You need to find a different way to do it. An approximate divide by 3 was fine for what I wanted to do, because it was just for timings, and they didn't need to be critical timings. It was just to work out roughly how many frames I needed for 3 seconds. I needed 1 second, 2 seconds, 3 seconds, and 4 seconds. 1, 2, and 4 were really easy to do. 3 wasn't as easy to do, and it wasn't as simple as just adding. It was working out. It was the other way around. It was dividing a number to work out how many seconds it took roughly. So divide by 3 was a bit awkward. So I made the approximation. Cool. So this should now do a jump, a fall, which will accelerate until we hit the ground. Then when we hit the ground, this flag will get turned off. So then the next time it gets turned on, this will kick in, the falling code. It will say, okay, we need to start falling again, and it will load the last index again. So every time we fall, it will start slow and speed up until we hit the ground, reaching a terminal velocity. And you'll see how he kind of dips through the ground a little bit. We'll work that out in a minute. There's because we can snap him to the. Actually, you can push up and he does a little jump. Because pushing up actually tries to move him upwards. It's kind of creating a jump. But obviously the fall routine is kicking in as soon as we leave the ground, and he's not jumping very high. So, but yeah, I mean he's actually moving around now. Can't go up ladders yet, but yeah, there we go. It's kind of cool. Okay, on that note, I'm going to go for a quick smoke. I need to top my wine up again, and then we will do the opposite and add a jump routine in. So we'll remove the joystick up, and we'll set the state to jump, and then we'll do the same thing, but we'll go through the table this way. Adding these values, subtracting these values from the player Y. Then when we get to the end, instead of capping it at this value, we'll turn off the jump and we'll set the state to fall. In fact, we just turn off the jump, the fall state will automatically be worked out. So once we get to here, we just stop jumping and then the fall code should kick in. So, right, be right back in 5 minutes, guys. Okay, cool. Let's do the next bit. So jump's going to be really simple. All we need to do, hang on, my Google decided to activate for some reason on that. There we go. Cancel that. Yeah, so all we need to do is find where the jump routine is. So we can get rid of this down now because we no longer need this. And instead of automatically moving the player up, what we will do is we will set the flag for jump. So we get the player state, and we turn jump flag on. Now we can't just jump all the time. We can only jump if we're not already jumping and we're not falling. So what we need to do first, before we allow you to jump, is check if we are jumping or falling or jumping. If either of those states are active, then we can't jump. So if they're not 0 when we do that comparison, then we skip. And that will set the jump flag. And likewise, at this point here, this is our fall check. In fact, I'm going to label it fall check here. Get rid of this bit here for now. So we need to check here if we are jumping, then we can't fall. So if player state is jump, then we need to skip all of this. So we exit the falling check. We don't need to do any checking of falling at this point, like so. So that brings us to here. And so what we can do here is a jump check, and we'll have an exit jump check. Let's group this together and then it's nice and clear. So likewise, if we are falling, then we don't need to do the jump check, so we can jump for the jump to here instead. If we're already falling, so we're not initiating a fall, we can also jump to there as well. So the only way we'll get to here is if we weren't falling in the first place, or if it's determined we're not falling because we're not jumping. So only if we get through this block of code will we initiate a jump check. And this is where we just simply check if we jump in. Check if we jump in. If we're not jumping, so if it's equal to 0, then we don't need to do anything else. We exit the jump check. Otherwise, we need to apply the jump table. So we need to do the same thing that we did here. Actually, we can do this up here. So we're starting a jump here, so we need to reset the jump index to 0. We start here like that, and then we just do the same thing we did with the fall. Actually, we don't actually need to do any of this because it's all handled here. Yep, we can get rid of that completely. So let me put, because this is just checking collision to see if we need to how was it, that one there? This is checking the collision to see if we need to start the fall. This is setting the flag. This is what's doing what pulling down on the joystick was doing before. This is determining whether or not the down action should be happening. Falling check, yeah. So we would do it here instead. But this is our fall, and we can start the fall here. So we do the same check again. We check with jumping. We put a skip in at the end, and then I'm just going to copy this entire code. So this is how we fall. We take the player index, jump index, we load the value and we add it to the player Y. This time we want to do it the other way around, so we're going to start with the player Y and we're going to subtract our fall index, which means we need to set the carry flag, and then we store the value in player Y, and we increase the index this time. So increase there, and we compare that to the length of this array. If it's got to the end, so if it's equal, then we'll do something. Otherwise we can skip and just store the value in player jump index. If it has got to the end, we need to decrease it by 1, just so it's not off the end here, it comes back to this value. And then we need to take the player state and we need to clear the jump flag, and we do that by ending it with that. And it's as simple as that. That should be enough. I mean, we'll have to tweak the jump table a little bit to get the height that we want. I forgot to put the tables. Yeah, but I always forget to do this all the time. It's because I look over here and I see what it's called and I just put it in. I don't think to put the label in at the beginning, but oh, it's letting us still keep jumping. So we need to work out why it's doing that, but we have got a jump now. So let's work out why. So if I just hold down to the up button, It jumps all the way up. Oh, that will be because when we get to here, it's just checking to see if either of these are set, and when we reach the top of our jump, all we're doing is clearing the jump flag. We're not setting the fall flag, so we need to set the fall flag as well. So we'll clear the jump flag there, and then we'll set the fall flag here. That should prevent that from happening. Cool. There we have it. We've got very, very basic jump. And because of the way we did the pre-calculations in here, using this extra label, we can tweak this jump table a little bit. So I'm going to split it over 2 lines just so it's easy to read on screen. But say we wanted to slow down a bit more gradually, so we could just add a few more of these values in. I'm going to split it over a few more lines just so it's a bit easier to look at. You can even put some zeros at the top so that it will hold the position as you reach the top. Now we'll jump a bit higher, but it should be still nice and smooth. What's that not? I keep forgetting I've got to close it down every time. Cool. So the other thing I want to do is fix this. So you see how he's kind of gone into the ground a little bit here. So the way we're going to do that is in our fall routine, in this area here somewhere, wherever it's been added. Yeah, so as soon as we're not falling, first thing we'll do, we'll check if we were falling. So we'll and if we weren't falling, we'll just skip over this bit. So we'll need to load the player state again here. Otherwise, what we're going to do is we're going to grab the player Y position. Yep, grab the player Y position, and we're going to AND it with F8. And what that does is it takes the last 3 bits off. So if you're at position 1, 2, 3, 4, 5, 6 or 7 pixel wise, it will snap it to 0. So let's do that first and see where it snaps us to. I think this is probably going to make us jitter around, but then what we do is we add a value to this as well. So this just allows us to snap to the ground. Thanks, Dom. Thanks for joining. Get some good sleep. As usual, this will be on VOD shortly after, and it'll get onto YouTube at some point when I get around to editing it tomorrow. YouTube takes such a long time to upload and process videos. Wine's going a lot slower tonight, which is good. Okay. Sign approximation works nicely. Yes, and I'm actually going to show you in a minute how to do this using sign, because it's a handy little Kickassembler trick to use. But let's just get this snap working first. Yeah, so he's bouncing a little bit, and that's because I'm rounding his value down, so he's moving up a bit. So I need to add a few pixels to this to get him to snap to the right position. I could use add, but because I know it's always going to be the last 3 bits, I'm just going to OR the value instead. And I'm going to OR it with 7 and see what happens. Which is the other end of the scale, basically. And the reason I use OR instead of using an add is because I don't need to clear the carry bit. Now, wherever I fall, yeah, I fell so fast I went through that block. So that wasn't great. I need to adjust it a bit more, so I'm going to lower that value 3 pixels. No, 2 pixels was the proper adjustment. Okay, it wasn't the right adjustment, it was just 1. There we go, perfect. Oh, he's still falling through that block. When he moves fast enough, he falls through too far. Okay. But why is that happening? I think that's happening because what we actually need to do, we get the value, we knock off 7 bits, except we knock off the last 3 bits, and then we put you back on. But if he's gone too far, okay, I think what we need to do instead is do a subtraction here and then AND it. Now it's going too far again, so let's change that to 2 pixels. Still going too far. What's happening there? So, well, let's have a look. Let's have a look at what value he's at. So let's just comment this block out for now, and just see what value he's at when he lands. So let's do this in the debugger. So he is at, where's his Y? 174. Is he in the right place there? I can't really see. 174 is 8 E in hex, so we need to kind of round it to E. So, okay, what I think we need to do in that case is, we were right the first time, we need to subtract 6, we need to AND it, and then we need to add the 6 back on again. Perfect. So what was happening there was we were getting the value 8E, right? And so what we were doing, we were ANDing it with a value F8, which would have returned the value A8, and then we were adding our extra value on. What that meant is, if we were moving really fast, instead of landing on AE, he would have landed on B2, and when you AND that with F8, you get B0. So then when you add you're 6 on, you get B6, so you're 1 extra character down the screen. So instead what we do is we subtract 6 from it, because 6 will give us the A8 that we're after, ensuring that we do all our rounding on the upper side instead. And yeah, by doing jump this way, you get full control over it. This is how jump should be. I don't like games where the jumps are uncontrollable, except Doc, but it's deliberate in Doc Cosmos. So yeah, you can see when I jump, I can move around. This will also have the advantage as well, because we've got no up collision here. If I go into Charpad and I just add, we have a tile that will do this. No, we don't. I'm going to create a new tile. That should be 256 anyway, so let's create a new tile. Don't know why that's gone that colour. Let me go and find where that character is. There it is. Where's my character editor? There it is. Get rid of that. There we go. So this tile here, I'm just going to add some pieces like that, and I'm going to put that. Where's my tile drawer? That one. Like that, and then I'm gonna export the tile set, and export the map. Oh, I've got this extra row down here. I don't know why I've got that, but now, yeah, I can jump up 3 platforms. And that's because we've got no up collision, but we have got down collision, so it's kind of nice. But you can do that because we've got no side collision, so you can kind of fall and. Okay. Let's fix that map while we've got it there. With height 10. Oh, because our height should be 11, I think. Yeah. So let's just add some tiles to the bottom there. That one will do. Doesn't really matter what tile we use there. Cool, save that. Whoops. Good night, Amok. Good to see you. And thank you for joining in, and thank you for joining in on Flubits as well. Sleep well. So I think we talked about, or we voted for single screen arcade, and now with the absorb mechanic. So I think what I'd like to see is a kind of cutesy candy world type of thing, as Forai was saying earlier on Discord. Be nice to kind of have something bubble bobble parasol stars, like, you know, cutesy kind of 2-player game, but with a kind of slight dark twist to it, in that you eat everything. It's a candy world in which you eat all the enemies as well. So anybody feels up to kind of doing tiles, multicolored tiles, with a candy world kind of theme, that would be really great. I'm gonna give it a little bit of a go myself. What I'd also like to see as well is I want to try and avoid having a black background. So clever use of contrast in background tiles to make it look more colourful would be really good. Use bomb jack or parasol stars as an example. If you look at bomb jack, find an example. Okay, so yeah, here's some screens. You can see how they're using almost like a bitmap in the background. I mean, it doesn't have to be that detailed. Where did that go? But definitely something along those lines. Just so it's not... I'd prefer not to have a black background, and I think if we do it right, we can make it look really good. 16 color parallax scroll background. If it wasn't a single screen game, then that would make sense, but as it's a single screen game, I think a parallax background might look a little bit odd. Although you could have it move with your movement, I guess, a little bit to add a bit of depth, but it's probably not necessary. Yeah, look, Parasol Stars is a good example of a background. I'm not going to show my C64 version again, I'm just going to show the NES version. If the NES can do it, then the Commodore 64 should be able to do it, in my opinion. So this is the NES version of Parasol Stars. Well, it was until I clicked the wrong button. And they have got a lot of black in the background on here, but you can see there's a lot of colour going on as well. I went for the PC Engine version more. And you can see from the PC Engine version that there is a lot of colour in the background. But you can see how it's contrasting. They've just used kind of blues, and they've used pastel colours in the background and bright colours in the foreground. So yeah, we can do it if we're just careful with it, and we can use PAL line blending as well to make more colours in the background and make it stand out a little bit more from the foreground stuff. Actually, these power-ups, if we have some kind of collectibles, then we'll probably do them with character sprites. That's where these will come in. But I mean, let's just have a quick look. Let's see what we can do just in a few minutes in here. So if we just make all the background this, like this. And we've got multicolor as, so we're not even using multicolor yet. So let's actually force it into multicolor mode. I'm not going to save this version. I just want to try some stuff out. Okay, and let's fix the colors on those tiles. So we're not using that. Green's fine. That looks like it's the top half. So let's just make that red for now. And make the bottom half kind of purple. Doesn't really matter what color they are for now. Let's take that off multicolor and make that yellow as well. So we've still got a ladder in there. Okay, so already it looks like a cake, to be honest. But to make that kind of, yeah, you know, you can make kind of cakey colors. But then in the background, these empty spaces, you can just, if we just fill that char up, let me find the thing and use multicolor mode, we can use any colors we want because we haven't set them anywhere. So if I'd set like light green and purple, for instance, or light green and grey, and then set this to purple and do this, in fact, it looks bloody awful, doesn't it? But yeah, we've got a shade of purple that infuses blue with it, and then you could cut things out of that. So there's a lot we can do to make it look a lot better. Oh, I got really itchy here. Do we need more browns? You make more browns with that colour. Oh, my door. You could make more browns actually. I don't think we need more, but as Andy says. But yeah, if somebody wants to take on the task of messing around with the sprites to come up with a candy world, let's try and make the background really colourful as well. I mean, I don't think it should be a solid colour like this. I think it should be kind of like the Parasol Stars thing, where they've got some kind of stuff going on in the background. You know, something that is obviously background, but is a bit more than just a solid colour. They've got lots of nice little things going on around here. So yeah, just look at those sort of games to get some inspiration, and share it as you go along. If you want help to do it, I mean, we should collaborate on these things. So okay, what should we look at next? So we've got the player in. Let me discard that before I actually save it. So we've got player jumping and falling, colliding with the ground. We can put side collisions in, I guess, now as well, because we want him to be able to. Let's have a look what we got. Oh, we could put his animation in actually. We could have it so if he's walking, he plays an animation. Let's do that actually. I think that's a really good idea. So what we're going to do is we're going to go into here. Just to let the guys who are signed up with me on Patreon know, I am still working on the third installation. It's coming along, but it is taking some time. In between everything else I'm doing. It will come eventually. I think we're always going to be slightly behind the stream, and I think as time goes on that's going to lag a little bit more as we go on. However, there isn't going to be a stream next Saturday. There will be one on Thursday, but there won't be one on Saturday because I have family around and I'm not going to have the time to do it, unfortunately. I'll have to wait 2 weeks for the next one, but that's plenty of time to plenty of time for you guys to kind of tweak around with the graphics, play around with the code, and it gives me a bit more time to catch up with the PDFs as well. Oh, I will keep doing the PDFs, yeah, absolutely. In fact, the more I do them, the more I realise that when we do finish this game, I'm actually going to re-edit them all and release it as a self-published Amazon book as well. I think it just makes sense. Might as well, it's all there, so it would be useful if it was in a format that didn't rely directly on the stream. Yeah, I do need to convert my son to the retro. Okay, so we're going to add 3 new states. We're going to have state walking. In fact, no, we just need 2 actually. We're going to have walk left, walk right, and they are these 2 bits here, nice and simple. And then we're going to have player walk index, and then in here we're going to have player walk left. And again, I'm going to do this just so we can mess around later if we need to. And player walk right. And then we're going to put the frames that we need in there for those. So those frames are 1. They start at 24, but are they actually at 24? I can't remember where we've actually put them in memory, so... assets, player sprites start here, so that's actually frame 64 where it starts, not 24. So it starts at 88. Yeah, my maths is going. And I'm not even getting through this bowl anyway, but my maths is definitely going. He says, greedily drinking more. So 64, 24, 88. Okay, so our walk frame is going to be in here. I'm not going to convert them to hexadecimal, there's no point. I'm just going to do it like this. We're not doing any kind of actions on these, so it's easier just to write them like this. And I'm guessing walk right is... Actually, that was walk right. Yeah, that was walk right. And we need to make walk left. What's that? That's jump, isn't it? So let's copy those, put them in... Oh, hang on, I've got the wrong one, that's why. That's better, right. So yeah, walk left was that one. No, walk left is at 16, so this should actually be 80. And walk right is at 0. That's 64. Cool, so we know what frames they're going to be. Have I always been good at maths? Yeah, it was my best subject at school, that and chemistry. I did really well at primary school at maths. Cheers, Faroy. Thank you for joining the stream, and thank you for all your great assets, by the way. I'm going to get you doing more of those. Sure. Yeah, I've always been pretty good at maths. I think that's why this kind of programming appealed to me, to be honest. Although this stuff does not help with your maths at all, makes it worse. You think you're better, but you're not. That's why you've always spent too much at the end of the night. Okay, so we need to set these states if we're walking left or right. So interestingly, what we need to do is we first need to definitely need to clear these. So in the player control, we're going to start. Whoops. We're going to start by clearing those flags. So remember to clear a flag, 255 minus the states you want to clear. So that if neither joystick direction is pressed, then it will assume that we're not walking in any direction. Whoops. I'm going to shrink this down a little bit because I think it's this that's making it hard for me to scroll this. Yeah, that's better. Yeah, I think it makes me a bit lower than others, to be honest. Okay, so what did I just do? Where did it go? Yeah, so okay, I'm making sure I clear the left and right state, and that's important because you need to, if you let go of the joystick, you need it to register that you're not walking either way, so you can set the correct frame. So we're going to do it like this, and then in the left and right, if we're moving left and right, in other words, if we get to this position here, so here basically, then we need to set that flag. Like so, and we need to do the same in the walk right. And that's kind of it. That's kind of all we need to do, really. So now it knows when we walk in what state we're in, whether we're walking left or we're walking right, but it also knows if we're jumping or we're falling. So all we need to do in draw player, so this time when we go to draw the player, at the moment the sprite is set here. This sprite pointer here is set in this frame. Now we can change this. We need to change this based on what we're doing. So we'll just put some just so we know that we're doing the right things here. So we need to load the correct frame and store it in this sprite pointer. So first of all, we need to know, are we walking? So and what we'll do is we will use Y as our frame. So we're going to assume that that is our frame. So when we're not walking, this is what frame we're going to snap to. We'll change the way that works soon. We'll probably use some self-modifying code here. I'll explain in a minute, but for now, this is the value that we're going to set in the sprite pointer, the Y register. So we'll call this label set frame because it's where we're setting it. And if we're not walking left or right, in other words, if we do this and it's 0, then we'll just jump to set frame. Otherwise, if we are walking left to right, we need to do another comparison. We need to make sure that we're not jumping or falling, because if we're jumping and falling, then we also don't want to do the walk animation. So this time, if either of them is set, so if it's not 0, then we jump to set frame. Otherwise, we need to set the Y to something else. Keep that separated. And so, what we're going to do, again, we're going to do this comparison. Actually, the first thing we can do, if we are walking, then we will get the walk index. We'll get the X version of it, increase it. We'll make sure that these are both the same length. So what we'll do is we'll compare it to we'll just compare it with one length. As long as these two are both the same length, then it doesn't matter. If it's not equal to that, skip. Otherwise, X with 0. And then we can... Now we need to know which of these two we're grabbing. So, which is what we were doing here. So now at this point, X contains an index. So if we're walking right, and this will be left. This needs to be tables. So yeah, I almost forgot to do that. That should not be that, it should be that. Player walk left. X because we set the X here. And then we can jump to set frame. Otherwise, we grab the player walk right into set frame. And that should be enough, but what we're probably going to see is that this moves very, very quickly. Yes, we could do that. If we keep it to 8 frames, we could just increment this value and end it with 7 and save it, so we didn't have to do this comparison. But we may want to change this. We may want to reduce or increase the number of frames here. That sort of optimization is the sort of optimization you do at the end once you know what your frames are going to be. There's no guarantee that we're going to keep 8 frames, because if we want the player to get bigger as he eats things, and he's going to walk in both directions, that's 16 frames currently per size. So if he's got 4 sizes or even 3 sizes, that's 48 frames. We've got, I think, 159 frames. So we've got to be careful how we do this. 159 frames, and we'd use 48 currently to do 3 sizes for the player. So if we up that to 6, that's now over half of our frames. For now, I think just we can keep it like this. And if we need to optimize later, because it could be we reduce it to a 4-frame cycle. If we reduce it to a 4-frame cycle and get rid of these frames, then we can use the and with 3 instead of 7. But for now, we'll leave it like this. So let's try that. Of course, it never works first time, does it? Branch not equal right. Oh, I forgot to do that properly. That's that line 143. Branch is not equal right. That should be a plus. That's why. Seems to be the only problem though. That's pretty good. And we're not seeing any animation. Okay. Let's think through that. It goes to draw the player. The first thing it does is draw the player frame. So we need to know if these are being set, these values. So let's load that in the debugger from the right file. This is where the debugger is really, really handy. We need to find our location, which should have a label. We're looking for player state here, and this is loaded in fairly near the beginning, so we should be able to scroll and find it. I've got 2 debuggers running here. Let me close them both and reopen it. I don't know which one's which now. Wrong one. Jump and fall, player control, draw player, collision point, player X, player state. Okay, so this is our value 92E. Put it into this mode. 092E. Let's go to 092E. So our state is 0, 0, which means we're not jumping, we're not falling, but we're not walking left or right. So the walking, oh, this doesn't seem right. So if I jump and fall, you see it going 1, 2. If I walk left, sorry, if I walk right, it goes to 4. If I walk left, it goes to 4. So I think I've probably got those flags wrong. 2, 3, 4. Walk left, walk right. 3, 4, 5. Okay, these look correct. Let me just, yep, I'm gonna space them out so that they're all equal. So they look correct. So maybe in our joystick control, play control, here we go, left, state walk left, state walk left, right, there we go, that's one thing that's wrong. Okay, let's try again. Okay, so we're getting the correct state there now, 4 and 8. So now we need to check. Just close these things down. It's getting in the way. Okay. So now we need to check why that's not applying. So we are getting into here. Where is it? Draw player. See, this is starting to feel like it needs splitting up. Are you storing the new sprite pointer? Yeah, it should be storing. Oh, yeah, you're right. It's because what I'm doing, I'm loading the value, but I'm not putting it anywhere. In fact, I think I can do that on there. I think I can do load y, x. There you go. I was loading the accumulator instead of y. Good spot. Except now he's just going into a floaty mode. So it's like it's not incrementing the walk index. So let's check on that. We should be incrementing the walk index. Yeah, okay, it's because we're incrementing it but not storing it, so we need to store that here. Cool. So it's working, but our animation is very quick. So I'm going to show you a trick. And notice when he jumps, he's always facing that way. But we'll work on that in a minute. Also, when he stops, he'll face that way, regardless of which way I'm pointing. But we're going to use some self-modifying code for that. But first, I'm going to show you how to slow this animation down. A little trick I use. So you've probably seen when we do our dissector stream that there's counters just continually counting round. I like to have one of those. I put it in 0 page. I'm gonna put it at 20. I just call it ZP counter. Like that. And then all I do is in my game loop, every frame, I just increment it. And so now, this value will continually tick around. Once every frame, it will tick around. And the reason I do that is because then, in things like this, so with the walk index, so this block of code here is what's incrementing our walk index. So I can do a quick check in here. I can say, load my ZP counter and it with 3, and if it's not 0, then skip this. And so what that will do is this will only happen now every 4th frame, because this ZP counter counts up. It goes 0, 1, 2, 3. Out of those 4 frames, only the first one would have activated because of this. And then it just repeats because we're ANDing with 3. It's just counting that 0 to 4 all the time, while this counter is actually counting everything. So you can use it in different places. So somewhere else you could be doing that, another place you could be doing that. So you can use powers of 2 as your kind of frame counters. It's useful for other things as well, but that's a sneaky way of kind of slowing things down a little bit. That still looks wrong. Why does it look wrong? What's he doing there? It's like he's... Let's just make sure I put that right under the right block of code. Am I supposed to have done anything here? Nope. If it's not 0, we skip. Otherwise, we do all this. Oh, we still need to load. So, problem is if we skip this block of code, we still need to have the thing in X. So I just need to load it first. So I load the X, and then if the counter is correct, then do the increment and store it. Otherwise, just carry on. So it should be fine. And there we go. We have a little guy who's running along now quite nicely. I mean, he's pointing the wrong way sometimes, but that's fine. I'll show you how we get around that in a minute. So we'll start by dealing with his his idle state. So at the moment his idle state is always facing right, and the reason that is because we put this block of code here. This is like the default frame, so I'm actually going to call this default idle frame. And what I'm going to do in not in tables, actually, no, I'm not going to put this in tables. I'm going to do it in directly in the joystick controller. It's probably not the best place to put it, but for now it can go there. So we know that this code is here. I'm going to label this. I'm going to call it default frame. Notice I haven't put the multi-label here because I need to reference this. So I'm going to reference raw player dot default frame, which is this opcode here, +1, which is this value here. And then what I'm going to do, I'm going to go and put that in the joystick control section. Which is, see, I'm getting lost in this file now. So if we're moving left, then as well as setting the state to walk left, I'm also going to store a value in that location, and that value is my walk left frame. And then I'm going to copy that chunk of code and I'm going to put it in here for my walk right code. And this time it's going to have 64. And that just means when you pull left and right on the joystick, it's going to overwrite that value. It's going to overwrite this value with these. It is self-modifying code, so I would normally like to write something like that in here, but that isn't going to work for this because that's too big a number. In fact, it might actually work because we're using immediate mode. It might allow me to do this and just ignore a lot of that number, so I'm going to try it anyway. Yeah, it's compiled fine, so. The only thing is the initial frame was wrong, so I am going to give it an initial frame instead of using beef there. I'm going to give it this this walk right frame. And now when I let go, he faces the right direction. Same when I jump as well, he'll jump in the right direction. That's pretty neat. That's fairly easy to do. It's not taking that long. And we've got a little animating guy who can collide and he can jump. And he's snapping nicely to the floor. He looks good. I'm going to get rid of this line on his head. It's kind of annoying. We don't need it now. So, actually, is that in the right? I don't think that's in the right folder now. Oh, no, it is. Yeah, there we go. Cool. Let's catch up a little bit. Animate arms behind the back run. I think it's a really nice walk animation there, actually. That's Monsters Go Boom did that. He's a really nice little character. And he's really chuffed that we're using it. I'm really chuffed that it's allowed us to use it. Very good. Hot damn, he's coming along nice. Yes, he is. He's looking very good. He's starting to feel like a bit of a game now. I mean, he's controllable. You know, we've got the basics of the game in there now. Animates nicely. Where's the beef? Will he slow down as more stuff is added to the screen? He shouldn't do. So let me show you a trick. You've probably seen code in progress done like this a lot. So what I'm going to get rid of this now because we don't need this debug code anymore. We know our routine works fine. Just going to shrink that down a little bit. So you've probably seen with work in progress kind of videos or screenshots of people's Commodore 64 games how they'll have colors in the border. Like they've changed the border color, and you can see kind of flickering bands of color. And that's a very simple way for a developer to work out how long something is taking in the code. So if I do this, before I do all this block of code, this stuff that we're doing every frame, I just increment the border color, and then when it's finished, I decrease the border color again. What we'll see when we run it is this white band, and this white band is how long. So when the raster gets to here, our code starts running. When it gets to here, our code is finished running. So we're not using a lot of time at all. The only time you'll start seeing slowdown is if this frame time fills the entire border. So we're using a very, very small amount at the moment. I mean, obviously the amount of time that we use will increase as we go along, but with it being a static screen game, it's not gonna take up much raster time at all, which is why I'm kind of keen to do something a little bit different with the characters. Have him eating things, you know, have the animations be quite complex, because we have got lots of frame time to do things with. That's why I was happy to make the collision kind of this accurate. I mean, look, we're stood right on the edge, one tap and I'll fall off, and that's nice. That's spot on accurate. Although that would appear, just as I say that, I think that's because his feet are no longer in the same spot. Yeah, he needs shifting along again. Let me put that animation in here and press play. Yeah, so that needs moving across one. That's correct. His feet still aren't in the right place, so he needs moving across one. And I'm guessing this is the same. So the next thing to do would be to implement a nice jump animation as well. So maybe we can look at that in a minute actually, and go through his his jump animation. So it looks like what he needs to do is when he's jumping up, he needs to go up to here and stop, like that, and then when he's falling, he needs to do the other way. I think we probably need to move these down because we're actually handling the jump ourselves. We don't need to have him slide up the screen, so we'll change that ourselves. Although looking at this, that frame and that frame is exactly the same except for their position. So maybe it's just a matter of adding this frame in, this kind of eyes open, arms in the air frame. But do you know what? I'm going to take a quick 5-minute break, and then we'll come back. We'll do another. I think we'll do another hour, and then we'll call it, because we're making good progress. I don't want to give myself too much to have to write in the PDFs when we get around to it. I like to try and catch up a little bit. But as soon as we're not going to do another one next Saturday, we will we'll do another hour. So be right back in 5 minutes, guys. Right, I'm back. I don't know if you're still there, Dr. Mix. I think you left earlier, didn't you? But I've added you to Fluebits now. I missed the PM, which was like 3 hours ago. I apologise for that. I don't see it in OBS. But if you're still there, now I've got access to Fluebits. Okay, so yeah, at the moment he's moving 2 pixels per frame. I mean, what we can do if we want to slow him down a little bit, we can do the same trick that we've done with the Z pointer counter. So let's have a look. 0 page counter. Make it more. Yeah. Sacrilege. I wish you could make something like that. Sub-pixel precision would be amazing, but unfortunately no, we don't have that luxury. So we're only actually moving the player one of our units, but our unit is 2 pixels, so we can't change that. That has to stay the same because we're using half pixels. But we can see what happens if we just kind of only let it update on alternate frames. So let's find where we're doing the joystick update. Left and right. It's done here, and we add the player X here. So we could just put a thing. Now we still need to save this state, so we still need to come down to here. I'm going to call it skip update, and I'm just going to do a check here. I'll just do it left for now, but we will do it like this. It has 256 fractions. Wow. How is he handling that then? Is he just updating it? I'm not sure how he would do that. I'd be interested to know how he's done that. We're going to check the Z pointer counter, and if it's not 0, we're going to jump to skip update. So this is just going to slow him down going left at the moment, so we can just check to see what that's like. So that's his right, and it still works alright actually. It still feels good. I'm not sure though, it feels a little too slow. There's also a little bit of a glitch. I think his sprite is wrong when he's walking that way, which I did fix actually, I think. Let me just update that sprite just to make sure I've got the latest. But yeah, I think it is just a little bit too slow. I think it will probably feel better when there's stuff on the screen and you've got stuff to kind of run around and avoid. Okay, I just used the high byte. Okay. Yeah, I mean that would work. I don't think we need that much precision though. Oh yeah, that's fixed here, but feels too slow now. I quite like the speed. What do you guys think? Yeah, it's faster right than left because I've only applied the slow down to the left, so I could do a comparison. So that's 2 pixels every second frame, 2 pixels every frame. Every second frame. Actually, that is something I was considering as well. If as he gets bigger, he gets a little bit slower. Can't jump quite as much. That could be good, yeah. We could definitely do that. Yeah, using a second byte. That makes a lot of sense actually, because then you see, if we were doing that, we may as well just store. I'm trying to store the player X as 1 byte at the moment, but we could quite easily do it as 2 or more bytes. The whole reason he's moving this fast and not this fast at 1 unit is because we're trying to use half pixels to avoid him having to deal with this most significant byte over this side of the screen. So we could in theory do, if we use 2 bytes and he was allowed to move 1 pixel at a time, so we didn't use half fractions, and then with the second byte we could have 128 fractions on that side, up to 128 fractions. I mean, we wouldn't need that many, but you could do it like that. We'd have space for that, and then there'd just be a little bit of conversion when you were converting the actual location. I feel like we should try that. I feel like that's an interesting thing to try, because if we do go down the route of the player being slower when he's bigger, we wouldn't want to slow him down too much. You know, jumping from 2 pixels a frame to 1 pixel a frame, you might just want to slow it down ever so slightly. So yeah, let's give that a try actually. Let's try that. So we're going to have to make quite a few changes to this. So first of all, let's restore this bit of code back to what it was. Okay, cool. That's correct now. Let's start by restoring single pixel precision. So let's do that, and now we will do this instead. So now we've got 2 bytes. I don't know why I'd set that to 1. I'd set it to 0. So when we draw the player, we now need to take both of these into account. So let's start by doing that. There's our draw player function. It is. And it is setting the position. So we load the value from player X. Okay, let's do. Yeah, let's commit. That's a really good idea, actually. Where am I now? This is in. Let's check this is actually the right folder. Yeah. Oh, god damn it. I've got the code here. Okay, cool. I'm just going to double check before I do anything that this is actually in GitHub. I have had cases where it's been pushed into the wrong place. And because I've set this up for flu bits, yeah, that's fine. Okay, cool. I have committed it with. Actually, did I commit it with any other changes? Let me just see what I've committed. Let me run it. Yeah, yeah. Yeah, that's fine. Okay, so that's cool. Right, we've got it all working. So I'm going to get rid of this now as well. Actually, I'm going to leave that there because we can probably use that for wall collisions later on. It's a nice reminder of what we were doing. Yeah, okay, so let's start by looking. So what did we do? We did half pixels, didn't we? So now we're going to use this. So this will be our low pixel accuracy. This will be our least significant bit. This will be our most significant bit. But I think let's do an extra 4 bits of precision. So this would be 1/16 of a pixel accuracy. So that means when we draw the player now, we need to, when we set the player's position, this was doubling that value. Thank you for the follow, Luminous Monkey. Welcome to the stream. Does this? No, unfortunately it does not support 16-bit operations other than addressing, yeah. It's quite frustrating, but you get used to it. So let's think of what we've got. So we're going to have a value. Say we're at value 1. I'm going to do this in big endian format just so it's easier to read. So if these are our two bytes, so that is position 0. So with 16th of a pixel accuracy, that would be position 1. And these 4 bits are going to be discarded. So we need to shift everything along 4 bits to the left. Is that right? To the right, sorry. So, we need to do this. We need to shift this one and then roll this one. So, this is going to be fun. So we've got player X, we've got player X plus 1. I'm going to store these in temporary variables. This is our most significant bit, so we need to shift that first. So we're going to shift that. And then we're going to roll this one. So this bit goes into the carry when we shift this, and we need to put it on the end here. So we need to use roll on the second one. And we need to do that 4 times. So let's put a little note to what we're doing here. So now temp 2 is this one, temp 1 is this one. So temp 1, we can take that and we can store that in the X here. That's correct. And now we need to set this sprite MSB, and that will come from this one. So if temp 2, if it is it's 0, then we need to clear it, otherwise set it. Okay, that's good. We'll worry about Y later. If this works, we can worry. In fact, we probably don't need this level of precision on Y, but we can change that as well. Okay, so that should now give us. Okay, so what we should see when we run this now is it's going to move incredibly slowly. We've got errors. Where have we got errors? Oh, because I've still got. Where did I put that? There it is. I'm going to leave that there just so I can. I'm going to have to go through this code later and remove all these weird comments I've dropped everywhere. So it should move, but it's going to be incredibly slow. No, where is he? He's in an odd place. That is because our collision is now using the wrong values. Let me start him in a better place. So let me just move him over a little bit. So let's move him over that much, just so I can see him. Yeah, so his collision's off now, and that's just because when we're doing our calculation, we were basing it on half pixels. So we need to go and find his half pixels. Also, he looked to be in completely the wrong place then. We'll figure that out in a minute. Let's get his collision correct first. So this is where we were getting his X position, and we were doing. No, this wasn't. It was this one. We were dividing by 4 here because we were using half pixels, but instead what we need to do is we need to divide by. Thank you for the follow, Encrypted Feelings, and welcome to the stream. calculate X and Y in screen space. So we're still gonna work on the value in no. Okay, so we need to do the same thing again. So the same stuff we've done up here. Oh, this file's getting too big now. So this thing here, we need to do it again. So this is a good case for kind of reusing code somewhere, but for now I'm just going to drop it in. We can always fix it later. So at this point, temp 1 and temp 2. Temp 1 is going to be our player X times 2. So I need to compare to the border offset. So this border offset now needs to be in proper pixel space. Yeah, this is just needs to think of it as a 16-bit value. Yeah, it's just getting a little bit more complicated because all our comparisons were done via this. So the first thing we need to do here is check if our upper bit is anything other than 0, then we're definitely not in this border and we can jump to here. Otherwise, get the lower value and set it and compare it, or snap it to this edge value here. This bit's kind of pointless now because I think we're gonna not wrap at the borders. We're gonna go. Yeah, we're probably gonna block ourselves at the edges, but that's fine. We should do rounding too. Yeah, I mean we can do rounding if this works. It's a pretty easy job to do rounding as well. It's just whenever we read that lower value, we just make sure we add, what it'd be, add 8 to it, and make sure we carry anything over to the upper byte. Yeah, but let's do that later. It's fine. Okay, so how do our pixel offset? Our pixel offsets now need to be in normal space, so we'll go back and fix that quickly, which was in here. These need to be doubled, so we're no longer using half pixels. So at this point, temp 1, which is our lower byte, we need to add the pixel offset here. The carry will be set if the pixel offset takes it over into the next one, so we need to blimey, this is getting confusing. Need to store that back in there, and then we need to load this one. This is going to be a load of fun to explain in a PDF later. So there we go, and then we need to subtract this from this. So take that one, subtract it, all of that in there again, and then we need to do subtract here. See, this is the beauty of doing a single screen game. We've got so much raster time, all this doesn't really matter. If this was in a full color scroller in Doc 2, I wouldn't think twice about attempting this, I just wouldn't do it. So now temp 1 and temp 2 are the exact values with the border offset taken off and the pixel offset taken off, and with the 4 bits on the end taken off. So now we need to do this again to divide that result by 8. And now temp 1 fact, you know what I'm going to do? I'm going to load temp1 there, and I'm going to get rid of those, just to make that a bit simpler. So that is our collision. So let's give that a try. There's probably going to be a few things wrong with this, but let's give that a try. Okay, I'm not sure where he's getting stuck there. He's definitely hitting something. Yeah, see, I should have thought about this when I began, really. But this is the beauty of doing it like this. So what we can do is the little bit of code that we had, which was drawing our this bit here. Where was it? So this was loading the colors. This was getting the position. Load of color charcoals X. Is the character at. X and Y. Okay, so I'm gonna, at this point here, I'm gonna load the, was it tables? Hang on, where's my get character at? Oh, I'm just going to do it in there actually. I'm just going to put a debug in where we're getting the character from here. So as well as loading the value, so just before we load the value there, I'm going to... What character value do we have? Yeah, when it works, it'll work really well. It's a really good point. I never actually thought to do it like this, so I'm kind of glad that you've mentioned it. And this is what this stream's about. It's about taking on little challenges like this and trying them out. I mean, it's probably overkill, but I think if we implement it's gonna load that value, isn't it? So because this is debug, I'm gonna just transfer that to the X register, then I'm going to do that, and then I'm going to transfer the X register back again, and I'm just going to put a little thing in to say debug, so I know to get rid of it. Yeah, I think if we implement the character kind of eating things and slowing down as it gets bigger, that will be a really useful thing. So it looks like he's not moving left or right. That's interesting. But he's picking up characters over here, which is weird. So let's change his position and see what happens. Let's move him to there. And he's still over in the same place. So my suspicion here is he's being drawn wrong for a start. Because he's always over here, he's not going anywhere else. Let's go back to our draw player. So where should he be here? So this is 1/16 of pixel accuracy, so this should be 1008. So he should be right over at the edge of the screen. He should not even, we shouldn't even see him. So that was actually probably good, because that would mean he would still only just be on the screen. Oh, this is the high pixel. This is why. LSB, little endian format. Always remember, little endian format. I'm still not seeing him in the right place. That's now because that would probably make me see him a little bit more. So his position looks correct now. He seems to be in the right place. It's just his collision isn't. So he doesn't seem to want to move left or right either, which is kind of odd. Oh, because he's really slow, that's all. He is moving, just incredibly slowly. And then occasionally flicking over. Okay. Good that you committed. You should just treat the whole part right as earlier. I'm gonna play around with this for another 20 minutes or so. So at the end of this stream, which is going to be in 20 minutes, 25 minutes, we're either going to have this fully working with the new sub-pixel accuracy, or we're going to just revert it. One way is going to make writing my PDF much easier than the other, so... okay, so... the drawing is correct. I think the collision is wrong. This is fine. This is drawing where I'm actually landing. I can leave that there for now. Okay, collision point. So I think it's this bit here. So I'm gonna do this all in one, just so it's a bit easier to see. So that's dividing by 2, 4, 8, 16. We've now got the thing divided by 16. Taking the high byte. If the high byte is set, then we don't do anything. Otherwise, we try and clamp it to the border. Border offset. Add the pixel offset. Yep. Update this one. Subtract it and update this one. And then divide it by 8 to get the screen position. Let's have a look at what this is actually returning. So in here, I'm intrigued as to what this function here is returning. Well, actually we can see where it's returning. It's wrong here, so... yeah, it has been very good to try it out. I've not given up yet though. I do like the idea of having this sub-pixel precision. Oh, that's interesting. Yeah, it's my calculation's off, because if I move, the collision moves very, very quickly, whereas I don't, so... it's definitely to do with this. This bit's right. It's this calculation here that's wrong. So let's think about this. It comes into here. We get the position, which isn't altered at this point. We store the values. Then we divide by 1, 2, 3, 4. So divide by 16. Whoops. Store that value. And I wasn't doing that there, but I am transferring it, so that's fine. Dummy by 2 pixels, and the high bit of the second byte would be single pixel. Code would still be most invalid, just need refinements for accuracy. Yeah, the problem is because he's moving 2 pixels at a time. I think I would have preferred. I think I would have preferred it to be 1 pixel if we was going to do that. But to do it as 1 pixel, we need to do it like this. We need to use that ninth bit. Because unfortunately the Commodore 64 screen is 320 pixels wide, so you need the 9th bit to do anything with single pixel precision. I think this is still going to work. I think I'm just the maths is just kind of not quite right. I'll get it there in a minute. Who is this Epic? This is a bot, obviously. Okay, so at this point we've got it at the right precision. I can check that actually. If I put a break here, so this is a nice feature of this is a nice feature of Kickassembler. If you put a dot break in and run it from the right file, we get a break point here and we can see exactly what's going on. So now I can actually check at this point and see what's happening. So we've got temp1 and temp2, so I'm expecting those values, because we haven't done anything, should be this divided by 4 divided by 16. So I could work that out in my head, but I've had enough wine that I think I need to do this properly. So let's do 480 divided by 1048. So we're looking to have the value. Oh, of course it is. It's just shifted 4 across. It's really dumb of me. So we're looking for temp1 and temp2, which are at positions 2 and 3 in 0 page, to be 48. Where's my memory address? Memory, not that one. Yeah, memory. There we go. And sure enough, the low byte is 48, the high byte is 0, so that's correct. The value at this point is correct. So we're good up to this point. It could be to do with this border offset thing. So let's have a look. So we check the high byte, because if we're in this most significant byte area of the screen over here, then we're obviously not in this border area. So we can skip this comparison. And this comparison is just checking if that value is less than this border. Then just snap it to that border. And then we add the pixel offset. That's fine. And that gets stored in temp1 as well. And then because the carry could be set here, we add 0 to temp2, just to make sure that the carry gets carried over. Then we take temp1 again, the least significant bit, and we subtract our border offset. We make sure we remove this border piece here, store the value here, and then because we're doing 16-bit subtraction, we need to subtract 0 from here, and then if it goes less, then so if we're over here, for instance, and we subtract the border offset and it takes us into here, it makes sure it decreases this high byte. So that's correct. So at this point here, I would expect those values to be instead of 48, they would probably be 30 in hex. Let's try that. So we've got a break to enter as well. Thank you for the sub, Luminous Monkey. Yeah, see our value's wrong here, so we'll check that out now. Thank you very much for the sub. As a sub, you're entitled to create an account on Flubits, so you can connect live to the code. You can also join my Discord channel and make suggestions for my Dissector game stream as well. We did creatures last week. I'm not sure, I don't think anybody's voted on what we're going to do next week. There will only be a Dissector game stream next week. There won't be a Maker game stream, because I've got family around who I'm going to try and convince to do retro stuff. I think we're going to have an MK weekend, which means we're going to play all the Mortal Kombat and Mario Kart games from the beginning of the present day. It's going to be very interesting, because I'm pretty sure none of my children have seen the original Mario Kart or the original Mortal Kombat. It's going to be quite fun watching that. Creatures 2. Yeah, Creatures 2 would be a good one, actually. Airwolf. I mean, I am going to do Airwolf at some point. That is going to happen. That will happen at some point. We will improve it. We'll put the press fire to win in, and we will improve it. Okay, so at this point the value is wrong. We would expect that value to be 48 in hex minus the border offset plus the pixel offset. The pixel offset is very low, so we wouldn't expect it to be 7A. So there's definitely something going on wrong there. So I'm going to put I'm just going to move this break up a little bit. I'm just going to check what's happening when I've added this pixel offset here and stored it here. So I'm going to put that break there because it's at that point we've done the 16-bit addition and done any border snapping here as well. I think that's right. As far as I can tell, this looks like it should be fine. So let's put a break in here just to double check when we get there, and then we can skip over it and go to the next one. I think if this works, I'm probably going to end up splitting this PDF over two things, or at least taking twice as long to do it, because it's going to be quite a complex thing to explain to people. So this value is correct. So we've got 4800. So this is correct. This is our x value divided by 16, because our value is our value is 0480. So this is correct. This is what we'd expect. If we divide this by 16, we should get 48, which is what we're seeing in here. Now I'm gonna start again, and it should jump to the next breakpoint. So now we're at where is it? We are at this position here. So now what we should have done is just, if the value is less than the border offset, we should have snapped it to the border offset and just add the pixel offset. And the pixel offset, I found the problem. We're using temp 1 and temp 2 here, but they're also used here. So we're changing those values. So I'm just going to change them to there. So it's just a stupid bug. Not watching, and this is why you should alias things. So I think when this is working, I'm going to create aliases for these this low byte and high byte. I think we may have just found a bug. Okay, it seems to be working, but I mean the collision's definitely in the right place, but now he's falling through the floor. Which I can't explain. So let's think about that. Yeah, so the PDF. So what I'm doing. Oh yeah, I'm corrupting the blocks. That's a very good point. I am corrupting the blocks. Let me turn that off quickly. So what I do with the PDFs is for people who are sub to the stream. Or our patrons, which is another point, Luminous Monkey, you will be able to, if you contact me on Discord or through DM, I can send you the PDFs for the stream so far as a sub. I haven't worked out how to link subs to Patreon yet, but Twitch subs and Patreon subscribers get access to a PDF write-up of the stream, which is more like it's more like a tutorial. With the view to it being almost a complete kind of book of how to make games, basically. Okay, this is almost right, but the problem we've got now is that our player movements aren't taken into account, that they're 16-bit anymore. So let's go and change that. Yeah, so everything I do, I'm explaining as if it was for a complete beginner. So for a PDF of this stream, I'll have to explain exactly what's going on at every stage, and it's going to be fairly complicated. Well, not complicated, but it's just going to take me a long time, I think. The last stream, I think, sorry, stream 2. was a 4-hour stream, and it ended up being 40 pages of PDF, so it ended up being quite a lot. Okay, so I'm just gonna change this a little bit as well, because I don't like the wasted. There's some wasted bytes here with these, and they're not necessary really. Also, that'd be a little bit quicker as well. Yeah, exactly. We could create we can create some kind of swampy ground or something that slows him down. It's a really nice feature actually. I'm glad you mentioned it. It works really well. Okay, so player control. Yeah, so this is what we're doing now. So currently when he moves left, we're decreasing the value in here, and we're actually wrapping it round. I'm going to turn off the screen wrapping left and right, because I think eventually we'll just have him stop at the edge of the screen anyway. If we need to add the wrapping in later, we decide we do want him to wrap from the left side of the screen to the right, we can add it in later. For now, we'll just do a straightforward decrease of this value. So we'll do it with this. We will create a new variable here. We'll call it player walk speed. Should this be 2 bytes? This probably should be. Oh no, because we're doing it in 16, so it's fine as 1 byte. So let's set it to 4. So it's still quite slow, but we load the value in player X. We don't need that because it's actually in here. This is subtracting, so set the carry bit, subtract player walk speed, and then because it's 16-bit, we need to do the most significant byte. So the way to think about these most significant, this 16-bit subtraction is, this is the 16-bit value, this is the least significant byte, the most significant byte, and this is the 16-bit value we're subtracting, least significant byte, most significant byte. So if we wanted to subtract a higher number than 255, we just increase this, and now we're subtracting more. But you always have to at least subtract the 0, because if this carries, then you're going to need to, sorry, if this borrows, it's called when you do subtraction, then this needs to happen so that it can actually do that behind the scenes. Okay, so that's fine for that direction. Blah blah blah. We don't need this anymore because we're not doing the screen wrapping, and we just need to store the value, but that's already stored. That's already stored. Right, cool. So we'll copy that and turn it into an addition for this direction. So it's all of that, which we're going to replace with the same thing but the other way. Oops. Cool. Right, that should hopefully give us accurate movement. I'm gonna hold down until I go over to the other side of the screen. I need to make sure that when it crosses the boundary it's correct, which it looks like it is. It's absolutely fine. Just make sure when I go this way it's fine as well. Most pathetic jump in the world. But yeah, there we go. So we've got it. Now you can actually do some cool things with this. I mean, you could have it so you have inertia on the player, so when you start running he starts at speed 1 and moves up to 16. There's a lot of cool things we could do with that. I think the best use though is going to be having his speed adjust based on his size and based on what he's walking through. I'm going to remove... I am going to remove this debug because I don't want it to be there in the GitHub when I commit. Because this is going to be for everyone to have a look at later. And there's a lot of stuff in here now. I've also got to go through it and write it up, which is going to be fun. So this was the original speed we... No, was that the original speed? Yeah, this was the original speed we had. And now we're essentially 32 times precision to what we had before. There's still problems with the collision over that side. That's fine because I've got no side collision, but once I cross into the most significant byte area, this goes wrong. So let's fix that. Let's do... I just want to do the thing that Acmefin jokingly said before. Now we can do that. So this is as close as we're going to get to 1.99 speed. And I said, it would be nice if we could do that. And hey presto, an hour later we're doing it. We just need to fix this collision over here. So the collision here is wrong. So I wonder actually, I think somewhere between the slow speed and the fast speed in the middle would be nice. Yeah, see, that feels good actually. Okay, so let's have a look at what's going on with this collision over here. Okay, so I'm just going to re-enable that a minute. Problem is, that's now going to... Okay. I don't know what I'm going to do. I'm going to take... So we commit it to X, right? And then I'm going to do... Oh yeah, if somebody says, could we do this? I have to do it. I have to try it out. I can't admit defeat. I have to do it. And it was a change that took, what, an hour to do? It's complicated the code slightly, but I think it gives us so many more options. I think it's a really good addition. And I know the 1.99 was a kind of joke, but we've actually ended up doing that. So, well, maybe not 1.99. What's our accuracy? 1.94 is about as close as we can get, ish. 1.9375. Hang on, let me work that out. I think it's 1.9375. So 1 divided by 16. Oh, only here. 16. 2 minus 0.0625. Yeah, I was right. See, my maths is still pretty good. That in my head, that's not bad. Math juice. Okay, so yeah, so I'm just doing some quick and dirty maths here just to just so that I change the color and not the actual blah blah. Yeah, just clear that. I'm just adding the difference between the upper byte of the color and screen RAM to this collision lookup, so that when I store this value in it, it's actually just changing the color and not Oh, that's not changing the colour, is it? That's changing everything. Why is that changing everything? Collision lookup +1. Color RAM minus screen RAM. Is our screen? No, our color RAM is lower. Oh, because I need to do the upper byte of that minus the upper byte of that. Yeah, rounding should be pretty simple now as well. Okay, that did nothing, did it? It didn't work. So the only problem is we've got this collision problem over here, so I'm just trying to get it to draw something underneath the player so we know what's going on. Actually, if I draw it above the player, that might work. So I'm just going to grab this same information again. This time I'm going to decrease the Y, actually, I'm going to transfer, no, we're moving the Y there, so I'm just going to, oh man, this is getting a bit messy, but it's only a temporary thing, so it's fine, it's just for debugging. Just so it's not on the ground underneath us. Store condition, yeah, don't need that. Oh god, what have I done now? Oh, because I'm now loading it there. We're trying to restore it there. Just gotta remember to not destroy what it's doing. It's also not drawing anything above me. Yeah, let's put a breakpoint in and see what's going on when we get to that point. Actually, this would be good in the debugger. Actually, I think, because we can use the breakpoints in there properly. It'd be much better than trying to do it this way. So let's load it in the debugger. In fact, I'm going to go for a quick cigarette, and then we're going to fix this collision bug, and then I'm going to call it. I said I was going to call it in an hour, but I really want to fix this bug before we do. So I'll be back in hopefully under 5 minutes, guys. So be right back. And I'm back. Wow, Zork's debugger can go backwards as well. That's good. Really good. I'd assume that the guys who are doing the C64 debugger will probably add something like that eventually. It's certainly capable of doing that. They just haven't put it in yet. I'm only passing 8 bits to the collision routine. Let's have a look. So this bit is fine because this is just the offset into the sprite. So in here, no, we're definitely dealing with. I mean, we're dealing with only 8 bits on the Y, but we don't care about the Y. That's fine. This is definitely dealing with 16 bits at this point. Let's load it in the debugger. That's going to be the easiest way. So the problem is when we get over here, our collision is wrong. So let's go and find where our collision routine is, which is get collision point, and we need to look at all this data in here. I'm way past it. I'm gonna get collision point. So it's this bit here. And so when we run this routine is this here. Get character at, so it's straight after this function. So at this point basically we need to know what x and y are, and it's saying x is 1D, which is 29, which does seem wrong. So if I start the code again and I move over here, the breakpoint in there again, x is 2. It's like it's reset when we get to that point. Oh sorry, no, that's the wrong line, that one. X is 1C. Okay, I'm gonna hold left. It's never going above 1D. It's kind of locking to that. Okay. So that is like it's ignoring that most significant byte. It's getting to that point and it's clamping to that edge. So let's double check these routines here. So this shift here is what returns Rx. So let's put a breakpoint around this point, which is in here. So let's just match it up. So we've got, I wish it would put more, I wish it would put labels in this side, but it doesn't, unfortunately. Let's put it in this mode so it's a little bit easier for me to see it. Okay, so actually no, because we'll get no labels at all in that mode. And so this is our here, and we're looking to look at this point here. So this will give us the values in temp. Yep, that will give us the values in temp1 and temp2 before we divide by 8. And so we would expect those to be over this side of the screen, like 200 and something. In fact, 300 and something. He's actually got brown eyes. On this frame he's got brown eyes. It's only some of the frames he's got black eyes, so feel free to download the SpritePad file and change that. So let's go and have a look at the memory location at this point. So it's here. This kind of looks correct at this point, but F3, let's see what F3 is. And let's see what it ends up being when we get to this point. So F3 divided by 8 is going to be, bring up the calculator, programmer mode, 3 divided by 8, 1E. So we should be seeing 1E in here at this point. Yeah, that's because the return value is just the screen character coordinates, so it goes from 0 to 39. So 8 bits is absolutely fine there. We should only have an 8-bit value at that point. So let's skip that through. So we are seeing 1E there, so maybe this value is wrong. So what is the sprite position at that point? So the sprite is at 321. So if we take sprite's position in decimal, 321. We take 24 away from it, we get that, and divided by 8, 37 is what we should be getting. So we should be seeing 25 there. So this is where it's wrong. So it's correct at this point in that this section is working correctly, but this here is wrong. So we're taking this value and dividing it by 16. So let's have a look at what the value is at this point. So at this point we should have 321, because this is just removing those 16 bits off the edge. And I think it could be this that's wrong somewhere. I think I've done something incorrect here. We'll find out. That's so this is, sorry, just trying to match it up to the code. It's not as easy as it could be. Out there, that's this, that's that. So at this point here, let's see what happens when we get to there. Okay. 0142. And I think 0142 is 322. I mean, it's off by 1. Not sure why it's off by 1. Oh no, 322. So that's correct. So at this point we're correct. So we're correct there. This bit is what's breaking it. And all this is doing is comparing and subtracting the border offset and adding our pixel offset. So let's put a breakpoint at here. Because all this should be doing now is it's not even subtracting, we're just clamping it to this border if it exists. If we're in the border, it should be, well, no, not even that, it should be clamping it to the border. Yeah, so if we're in the border, it should make sure that the value is here and not here, somewhere in here. Just clamping this value. Probably don't need this anymore actually, but let's keep it there anyway. Just it shouldn't affect us. So let's have a look back at here. We've still got the same value here, so that's fine. That's again 142, which is correct. So we're correct at this point. Slowly stepping through until we find it. Okay. Then we're going to add the pixel offset, which is only going to be 2. X pixel offset, yeah. So we need to check this point here. So what we should see is 144, or maybe slightly higher, depends which one we're on. So that is here. Oh, and something's gone wrong here. So this value is wrong. X pixel offset. We've ended up with 103. X pixel offset. Temp 3. We don't use temp 3 anywhere. Yes. So we're correct here, but then this value is incorrect. And that's 04, so it should just be adding the contents of that. What's the accumulator say? The accumulator says, okay, let's go back a bit. So let's see what the accumulator is at that point. Let's clear all these breakpoints before we do this add. So we've got 142 and the accumulator is at 1 because that no longer has this value in it, and that doesn't have this value because here we skip it, so this actually needs to be set there as well. And that needs to be set there like that. There we go. And that's our problem. I think we'll find that works now. Boom, there we go. So yeah, it was, the problem was because before we were only using 1 byte, we were just assuming at this point that the accumulator had the correct value in it, but because of the 16-bit nature of it, it no longer did. Debugging. This debugger is brilliant. It'd be nice if it had more, like the cheat finding stuff that we were using, but it's good enough. It certainly helped us there. Definitely helped us there. Oh, where's it gone? There we go. Cool. I think I'm going to call it there. It's quite late. It's been what, almost 4.5 hour stream now. There's been a lot to take in there. We've done some nice work. We've got the character animating in both directions. He hasn't got a jump animation in yet, but he is animating. He's colliding with the floor. We've got him with nice variable 16th of pixel precision. Thanks for a nice suggestion from Mac Muffin. And can we call him Jiff and Jeff? Jiff and Gif. Yes. Yeah, we do need some names. I mean, what will be interesting as well, I think this is another really good reason to have this in, is with 2-player mode. If you've got one player who's grabbing everything, he then gets a disadvantage because now he's moving slower than the other guy. So I think this could work out as quite a nice game mechanic actually. You've got one guy, the guy who's collecting more is going to have a harder time than the guy who's not collecting as much. So it's kind of self-balancing in a way. It should be interesting, and combined with the kind of little fun mechanic of maybe eating each other at the final stage when you activate the exit, I think that'd be a nice little touch. I mean, completely pointless because you've completed the level, but just a nice little kind of twist at the end, a kind of bonus for playing 2 players if you like. Just try that again. I'm always pleased to see it working. And then we have our little guy moving around. Yeah, I think it is a fun touch. I think it's gonna add to it. It's gonna create a nice. The problem is I can walk right off the screen now. But what we'll do at some point is we'll block them to the edges of the screen so you can't go off the edge. Same on the other side. Cool. Yeah, thanks a lot, guys. As ever, there will be a VOD of this as soon as I finish, and I will update my YouTube channel with an edited version of it. PDFs will follow shortly, but they are taking a little bit of time. I think it's going to lag behind a little bit. There isn't going to be a game stream next week, but there will be a dissect stream. So anybody who wants to suggest a game, do so on Patreon, do so through Discord, and we'll look at doing something on Thursday for that. I'm just going to see if I can find somebody to raid. It doesn't seem to be. Anybody got any suggestions? Pop them into chat. came in with Retro Sunstream. I might do that at some point. That's a really good suggestion. Let's have a look. I can't see anybody on. Zork's not on. I'm just going to type retro in and see what I can find. Retro. Do you know what? I'm gonna raid the this Mario Paint Bob Ross again. I really enjoyed raiding him last time. It's kind of funny. He's just a little bit weird and wacky, so why not? Okay, let's set that up. Yeah, thanks a lot for everybody coming along tonight. I've not even managed to finish my bottle of wine. I am going to finish it off before I go to sleep, just to help me sleep. And I shall see you guys again on Thursday. So cheers guys, take care.